Welcome to Prelim Preparation 2026. So this is going to be your preparation to this year's trial. Reason why I did this is that I went through the past papers for trial. They're a little bit trickier compared to the normal November paper. So I wanted you guys to be well equipped for your trial, as it contains a lot of marks in terms of like your final mark. So, and also the nice thing is that if you can master this and if you can do well in your trial exam, that means the fact that your November you have less stress. So that is why I decided to do this. So I have a recording schedule, right, or a release schedule on which when each paper is going to be released. So the preparation is going to start now, as you see in this video. So this is the release schedule, right? So it's within each date. So as you can see, the fact that we have June when each paper is going to be released, right? And also we have like July, right? As you can see, July is going to be like double releases because of like it's close to August, because then you have 1 month. And then we have lastly August, which is going to be this, completing the entire trial papers from last year. So this was very important for me to make sure the fact that by the time you guys write your trial exam, all the provinces are covered, right? Welcome to Prelim KZN paper 1. As you know, the fact that this video has resources, and that resources is like exactly this video but in the PDF version. So to get the PDF version, just you need to be part of my membership. So I'll just, after here, I'm just going to show you on how to join the membership and also how to get the PDF, right? So that's what we're going to do now. So first I'm going to show you guys on how to join the membership. Obviously, you're going to search my name, then you're going to click on my profile, then you're going to land here, right? Then you have two buttons. You have the subscribe button, right? And you also have the membership button, right? So the join button is where you join the membership. So when you click on it, right, you'll see the fact that this is going to be the membership, right? Then it tells you what you get: membership, only videos, early access, you get it, priorities, and all that, right? So now, do you see the fact that we already have exclusive content, right? So this content is strictly on the membership, right? So now when you say join membership, it's going to load, obviously. Then let me just say yes. Then it's going to load. Then when it loads, do you see the fact that now you're part of the membership, right? So when you scroll down, right, is that you're part of the membership, meaning you have access to all the members, right? So let me just go like this, right? So you can see the fact that you have everything that's related to members, meaning it's from the videos, right, to the most recent post, right? Then also now how to get the PDFs, right? So under members, you're going to see the videos. Then when you go through post, that's when you're going to see my post. You're going to see post of like public, and also when it's written to members only, you now can see it, right? As you see the fact that every time when I release a video, I do say the fact that there's a PDF. So this is the PDF for the NBT past paper, right? And also this is the PDF for the master series, right? Then this is like the normal posts, right? Then do you see the fact that this is the PDF for what? This is the PDF for paper 2, May, June. And also this is the PDF for what? For paper 1, right? Okay, so now let's go to one of the posts, right? We see the fact that this is the access. Now when you click on it, right, it's going to give you like Google Drive, because it's a Google Drive. So don't worry, it's public, right? So then when you scroll down, you'll see the fact that the PDF is within two versions, right? Is that you have the actual, it tells you that which PDF it is, right? Then you're gonna have the question paper first, right? Then after having the question paper, then you're gonna have the memo. The memo is exactly how the video is, but now it's in PDF format, right? So all of them are going to be like this, where you get what? You first get the question paper, right? Then underneath it is the memo. Hope that makes sense, right? So that is how you would get access to this PDF. So now we're going to do solve for x. We're going to do question 1. The first one, it says solve for x, and they give us x squared minus 11x plus 30. So we're going to use our table, right? First, we need to find the factors of c. C is always this one, right? The coefficient here is a. the coefficient, this negative 11 is B, then C is going to be the one that doesn't have X, right? So C is going to be 30, right? So we know that 30 is going to be here. Then we're going to find the factors of, the factors of 30. So the first one is that when I say 1 multiplied by 30, right, I know the fact that I'm going to get 30. Then remember the fact that we're looking for the factors of 30. So I'm looking for, in such a way, the fact that when I multiply the factors, right, when I multiply the factors, I'm getting a positive. So how can I get a positive 30, right? Is when I say 1 multiplied by 30, I'm going to get a positive. Or if I say negative 1 multiplied by negative 30, I'm still going to get a positive 30. So we're doing it such that when we multiply, we get C, which is C is 30, the factors. Hope that makes sense, right? So the other one is 2 multiplied by what? 2 multiplied by 15, or we can say negative 2 multiplied by negative 15. Both of them, they're going to give me 30, right? Positive 30, very important, because C is positive. Then we're going to continue. It's going to be 3 multiplied by what? 3 multiplied by 10. It's going to be positive 30, or negative 3 multiplied by negative 10 is going to give me positive 30. And lastly, it's going to be 5 multiplied by 6. So it's going to be 5 multiplied by 6. It's going to give me 30. Or if I say negative 5 multiplied by negative 6 is going to give me positive 30. Then I'm just going to draw this line to create a table like this. Then taking those factors, we want it in such a way when I add, I'm going to get B. And we see that B is equals to negative 11, right? So it's going to be negative 11. So now we're going to start adding those factors. If I say 1 plus what? 1 plus 30, I'm going to get 31, right? That is not negative 11. But if I say negative 1, right, plus negative 30, I'm going to get negative 31. Also not negative 11, right? So I'm going to continue when I say 2 plus 15, I'm going to get 17, right? Not negative 11. When I say negative 2, mine plus negative 15, I'm going to get negative 17. Still not what we want. If I say 3 plus 10, I'm going to get 13. Still not what we want. But if I say negative 3 plus negative 10 is going to give me negative 13. Still not what I want. When I say 5 plus 6, I'm going to get 11, which is close to what we want, but we want negative. But if I say negative 5 plus negative 6, I'm going to get negative 11. So we know the fact that this is going to be our factor, right? And I'm going to highlight it in green. This is the two factors. So my two factors, it's negative 5 and negative 6. So now rewriting this is going to be x squared minus 11x plus 30 is equals to 0. Our two brackets, right? Our two bracket. Then you're going to have x here and x here. Remember, our factors is negative 5 and negative 6. So we know the fact that if I say minus 5 and minus 6 is equals to 0. So equate each bracket by 0. So it's going to be x minus 5 is equals to 0, or it's going to be x minus 6 is equals to 0. So therefore, x is going to be equals to positive 5 and x is going to be equals to positive 6. And that's how you'll solve for x for this question. So now we're going to do 1.1.2. It says again, solve for x. But the most important part, they say to 2 decimal places, right? The minute you see those brackets, you know the fact that you need to use the quadratic formula, right? So using the quadratic formula, we know that the quadratic formula is x is equals to negative b plus or minus square root of b squared minus 4ac, right? This whole thing inside so everything inside the square root, and the whole thing is going to be divided by what? It's going to be divided by 2a, right? So to use the quadratic formula, we need a, right? We need b and we need c, right? So the coefficient of x squared is going to be a, so that's going to be 3. The coefficient of x is going to be b, so it's going to be 9. Then lastly, c is the one that doesn't have x, so it's going to be 4. Hope that makes sense. So now we're going to substitute, right? So when we substitute, we're going to have x is equals to minus open bracket. Always put everything inside a bracket, right? So it's going to be 9, and it's going to be plus or minus, then it's going to be square root, and this is going to be 9 all squared, right? Minus 4, then it's going to be 3, and here it's going to be 4. Then everything is going to be inside a square root, and this whole thing is going to be divided by 2, then it's going to be 3. Hope that makes sense, right? So now let's simplify it. So it's going to be x is equals to negative 9 plus or minus square root. Then this is going to be 81, right? Minus, then sort out the other side, which is going to be 48, right? So it's going to be all divided by 2 multiplied by 3. It's going to give me 6, right? So clean up the square root. So it's going to be x is equals to negative 9 plus or minus going to be square root of 33, right? And this whole thing is going to be divided by 6. So this is the same as having x is equals to negative 9, right? Minus, so let me just do this, minus square root of 33, right? Divided by 6, or, right? Remember the fact that it's plus or minus. So it's going to be plus or minus. So the minus, then the other one is going to be plus. So it's going to be x is equals to negative 9 plus square root of 33 divided by 6, right? So now we're going to punch this into the calculator. When you punch that into the calculator, you find that your x is going to be equals to what? To negative 2,46. Then this one, when you say x is equals to, then you're going to get, what you call it, you're going to get minus 0,54. Then that is how you would solve this question. So now we're going to do 1.1.3, which is solving the inequality, right? So first, we need to look at both of them individually. Because of this, we see the fact that it's an exponential, and this is more or less of a linear, right? So looking at the exponential, right, and I'm just going to draw it so that you can see, right? I'm going to sketch 1 over 2, right, to the power negative x, right? I'm going to sketch that, right? So if I sketch that, I see the fact that this is the graph that I'm going to have. So this is the graph that I'm going to have. So this is how the graph is going to look, right? So this is what? This is 1 over 2, right, minus what you call this, to the power negative x. If you look at this, right, our graph only exists in the positive x-axis, right? So our graph only exists in the positive x-axis, meaning it doesn't exist here. So the inequality for this I can't solve it and saying the fact that this is less than 0, because that will be a lie, because there's no graph here. So always, right, so always for this graph, so this graph, so I'm gonna say so 1 over 2 to the power negative x is always positive, right? Meaning it's always greater than 0, right? And I'm not going to say greater than and equals to, because of this is the asymptote. The asymptote is 0. It doesn't equate, like it's not equals there. So for this one is that our first inequality, which is we solved, is that 1 over 2 to the power negative x is what? Is less than 0. So that is our first solution, right? So now, since we sorted out this, right, is that now we're going to ignore it and solve this inequality, right? So it's going to be what? It's going to be 3 minus x is what? Is less than and equals to 0. Take the 3 to the other side. So it's going to be negative x is less than and equals to negative 3. When I get rid of the negative, so we're going to divide both sides by negative. So meaning the inequality is going to change. So it's going to be x is greater than and equals to positive 3. And that's going to be your final answer. So your final answer is going to be this one and this one. So that's how you would solve this question. So now we're going to do 1.1.4. It says we need to solve for x for this. So when we're dealing with square root, we just want to make sure the fact that the square root is alone and take everything to one side so we can square both sides, right? So let's do that. So we're going to say what? We're going to say square root of what? Square root of 2 minus 7x plus 2x is equals to 0. Take the 2x to the other side, right? So when we take 2x to the other side, we're going to have square root right, of 2 minus 7x is equals to negative 2x. Then we want to get rid of the square root. So we're going to square both sides. So it's going to be square both sides. So it's going to be 7x all squared is equals to negative 2x all squared, right? So now the square root and the square is going to cancel each other. So we're going to have 2 minus 7x is equals to, then this is going to give me 4x squared, right? Then take everything to one side so that we can factorize, right? So we're going to have 0 this side is equals to 4x squared. Then this is going to be plus 7x and this is going to be minus 2, right? Hope that makes sense. So when you factorize this, you're going to have two brackets. So one is going to be what? It's going to be 4x, right, minus 1, and the other one is going to be x plus 2, right? So equate each bracket by 0. So you're going to have 4x minus 1 is equals to 0, or you're going to have x plus 2 is equals to 0, right? So here we're going to have 4x is equals to, take the 1 to the other side, so it's going to be positive. So therefore x is going to be equals to 1 over 4 here, and here x is going to be equals to negative 2, right? Then whenever you're dealing with square root, you need to check your answer, right? So now we're going to check our answer. So checking our answer. So when we check our answer, right, we need to make sure the fact that we're proving whether the left-hand side is equals to the right-hand side. So we see the fact that our left-hand side is what? Is this one, right? And our right-hand side is this one. It's 0. So basically when we're substituting, when x is equals to 1 over 4 or x is equals to negative 2, if we get 0, then that's part of the solution. If we don't get 0, then that's not part of the solution. Hope that makes sense, right? So now for x, so substituting, for x is equals to what? 2 equals to 1 over 4. Remember the fact that the left-hand side, so we know that the left-hand side is equals to what? Is equals to the square root, right? And it's going to be 2 minus 7, but x is going to be replaced by 1 over 4 because that's what we're substituting, plus 2x, which is going to be 1 over 4, right? And when we punch that into the calculator, we find the fact that this is going to be equals to 1. 1 is not equals to 0. So this is not part of our solution. Then you put a cross out of there. So we reject it, right? Then when we say x is equals to negative 2, so now let's do that. So it's going to be the left-hand side is equals to the square root, then it's going to be 2, right, minus 7, then this is going to be minus 2, then it's going to be plus 2, then it's going to be minus 2. When you punch that into the calculator, you're going to get your answer as being 0. So meaning this is part of the solution, right? So this is part of the solution. So this we reject, and this one we accept. And by me putting a cross here, I'm rejecting it, and thus leaving it like that, I'm actually accepting it. So that's how you would solve this question. Now we're going to do 1.2, right? So we see the fact that evaluate the following. So when dealing with this type of question, we need to check what is the common base. We see the fact that we have 2 here, meaning here we need to change it to 2. And this is great because of 4 can be written in terms of 2. So that's great, right? And since in the numerator we're adding, is that we need to be able to pull out a common factor, right? So we see the fact that here we can basically write this one as this one plus another number. So the following things that I'm going to do, I'm going to evaluate this and change it so that it has the base of 2. Then do you see the fact that this one is the greatest, 40, 25? I can write 40, right, 23 plus 2, which is going to give me this one. Hope I'm making sense, right? So let's evaluate this, right? So first we know the fact that we can rewrite 4 to the power 2011, right? I can write it as 2 to the power 2, right? And this is going to be 211, which is the same as 2 to the power. When you say 2 multiplied by this, you're going to get that as being what? As being equals to 4022. Hope that makes sense. So I've cleaned up the denominator. Now I want to clean up the exponents, this one, right? I know the fact that 4025 can be written as 4023 plus 2, right? So I'm going to replace this one so that it looks like this one so that I can pull out this one as a common factor. Hope I'm making sense. Now, so now with that said, let me replace everything. So we have the fact that 2 to the power, so I have 2 to the power 4025, right, plus 2 to the power 4023, right, and that whole thing, we know that it's divided by 42011. So let me just replace it with what we have established. We know the fact that this is basically equals to 2, right, to the power what? To the power 4, sorry. So it's going to be 4023 plus 2, right? And plus, then it's going to be 4. Okay, it's going to be 2. So it's going to be 2, then it's going to be 4023, right? And this whole thing is going to be divided by what? It's basically going to be divided by 2, right? And this is going to be 4022. Hope that makes sense, right? So now let's simplify it a little bit further. We know the fact that this is going to give me what? We can pull out, before pulling it out, is that this is an exponential root, right? So meaning, I know the fact that if I have a, and this is going to be m plus n, I can write it as a to the power m multiplied by a to the power n, right? So this is an exponential rule. So this is what I'm going to be doing. So that's what I'm going to be doing to the 420 plus 2. That's what I'm going to be doing there. So I know the fact that I can write it as 2. So it's going to be 2 to the power 4023. I don't have space, so I think let me go to the next line. Right, so I can write it as 4. So this is going to be 2 to the power 4023 multiplied by 2 to the power 2. And this is going to be 2 to the power 4023. And this whole thing is divided by what? Is divided by 2 to the power 4022. Hope that makes sense, right? Now I can pull out this as a common factor, right? So I know if I pull out that as a common factor, I'm going to have that 2 to the power 4023. Then what's left here? I'm left with this. Then this one, since I took it out, so it's going to be 1. So it's going to be 2 to the power 2 plus what? Plus 1, right? And this is divided by what? This is divided to 2 to the power 4022, right? The nice thing is that since this one, they both dividing and they have the same base, I can basically use the exponential laws by subtracting the what? By subtracting the powers, right? So this is the same as 2 to the power what? 2 to the power 4023, right? Minus 4022, right? And here is going to be 4 plus 1, right? And that the denominator, we do not have any denominator anymore, right? So now we know the fact that this is going to give me what? This is going to give me positive 1. So this is the same as 2 to the power 1, right? And here is going to be 5, right? Then you're going to say 2 multiplied by 5 is going to give you 10. So that's how you will solve this question. This is equals to 10. So now we're going to do 1.3, and 1.3 is that solve the simultaneous equation, meaning x and y, right? So what we do is that we take each equation and name it equation 1 and equation 2. Equation 1 is always the one that's linear, meaning it's going to be x is alone. So it doesn't have, it's always to the power 1. That is a linear function. And also y, we can isolate y alone or x alone. Hope I'm making sense, right? So the first one in our case is going to be equation 1. So we're going to take this one, which is going to be y plus 1 equals to 2x. And we're going to name it equation 1. And the second one by default is going to be equation 2, right? So it's going to be 3x minus y. Then it's going to be x plus y is equals to 0. And that is going to be equation 2. So we're going to take equation 1, right, and make y the subject. The reason why I'm making y the subject is that it doesn't have any number in front of it, right? So we're going to take equation 1 and make y the subject. So now let's do that. So taking that, we know the fact that we have y plus 1 is equals to 2x. Take the 1 to the other side. So we're going to have y is equals to 2x minus 1. And we're going to name this equation what? We're going to name this equation 3, right? So now, since we know that equation 3 and equation 1 is the same thing, but they just written differently, we're going to take equation 3 and substitute it to equation 2. So wherever I see y, I'm going to substitute by this. Hope that makes sense, right? So that's what we're going to do. So I'm going to substitute. So I'm going to substitute equation 3 into equation 2, right? So we know the fact that equation 2, let me just do this. Duplicate, cut it. So we know the fact that this is equation 2, right? So this is going to be equation 2. So wherever I see y, I'm going to substitute by 2x minus 1. So it's going to be what? It's going to be 3x. Then it's going to be minus. Then it's going to be 2x minus 1. Then here's going to be x. Then plus. Then it's going to be 2x minus 1, right, is equals to 0. So now let's clean that up, right? So when we clean this up, we're going to have this side as 3x. Distribute the negative is going to be minus 2x plus 1, right? This side is going to be x plus 2x. Then it's going to be minus 1. Then this is going to be equals to 0, right? Clean up each bracket. So we're going to have the first bracket as being x, right, plus 1. And the second bracket, we're going to have it as 3x minus 1, right? So now, and this is going to be equals to 0, right? So now we're going to equate each bracket by 0. So we see the fact that x plus 1 is going to be equals to what? It's going to be equals to 0, or we're going to have 3x minus 1 is equals to 0, meaning x here is going to be equals to negative 1, and here x is going to be equals to 3x. Take the 1 first, it's going to be positive. Then x is going to be equals to 1 over 3, right? But we're not done. Remember the fact that this, we solved just x. So now we're going to basically need to substitute so we can solve for what? For y. So remember the fact that in both our, in our 3 equations, right? The one that's in terms of y is equation 3, right? So what we're going to do is that we're going to substitute our x values into equation 3, because that's the one that's in terms of y. So now for x equals to negative 1, right, we see the fact that we can solve for y. So y, remember, is equals to what? Let's go up, is 2x minus 1. So it's going to be 2. Then x is what? It's going to be negative. It's going to be negative 1, right? It's going to be 2x then minus 1. So it's going to be minus 1. So the y here is going to be equals to what? It's going to be equals to negative 3, right? Then for x is equals to 1 over 3. Then it's going to be y is equals to 2. Then it's going to be 1 over 3. Then it's going to be minus 1. And therefore, we see the fact that our y here is going to be equals to what? It's going to be equals to minus 1 over 3, right? So that's going to be us solving our x and y. Hope that makes sense. So now we're going to do 1.4, right? It says 2 integers have a sum of m, right? Then they tell us the fact that, let me just highlight. They tell us that 2 integers, right? So we have 2 integers, and those 2 integers have a sum of n and have a product of n, right? So adding those 2 integers, we're going to get, it's going to be equals to m. Then multiplying those 2 integers, we're going to get it as n, right? Then they tell us the fact that determine the expression of the sum, right? The sum of squares, right, of the 2 integers in terms of n and m, right? So now let's translate whatever that they gave us and what they want, right? So we have 2 integers, right? So I'm going to let our 2 integers, so we're going to let the 2 integers, right? The 2 integers be what? B, I'm going to call them x and y, right? So b, x, and y. Hope that makes sense, right? So that is our 2 integers. Then what do we know? We know that adding our 2 integers, we're going to get m. So meaning when I say x plus y, I need to get m, right? The sum of 2 integers. Then the product, meaning when I say x multiplied by y, I need to get n. That is the product of integers. So we know the fact that this is the sum and this is the product. So that's the two information that they want, right? So this is the sum and that is the product. Hope that makes sense, right? Now they tell us the fact that determine the expression of the square of the two integers. So what they want, right? So what they want, right, is that they want the square of the two integers, meaning x squared plus the sum. Remember, the sum of the squared, so it's going to be x squared plus y squared, right? They want that to be, right, in terms of what? To be in terms of m and n, right? So we know the fact that we need to express x squared plus y squared in terms of what? In terms of m and n. So now our problem is how we're going to do that. But we know something, right? From this identity. So from the squared of from the perfect squared identity, we know the following, right? We know the fact that we know the fact that we have this using this identity. Maybe let me say using this identity, using this identity, which is the sum of squares, right? Which was not the sum of squares, using this identity, right, which is the perfect squared, and I'm just going to show you, right? So using this identity, which is going to be x, right, x plus y all squared is equals to x squared plus 2xy plus y squared. Remember the fact that the goal is to find this. So I'm going to basically take this y here so they can be in this form and make it the subject. So we know the fact that x squared, right, x plus y all squared is equals to x squared plus y squared, right? And it's going to be plus 2xy. So we want this to be alone. So I'm going to take this to the other side. So this is the same as x plus y all squared minus 2xy is equals to x squared plus y squared. But remember, the goal is to write this in terms of m and n, right? So we know the following. We know the fact that x plus y is m, and we know the fact that x multiplied by y is equals to n. So now let's replace it. So this is the same as having m here all squared minus 2, then this is going to be n is equals to x squared plus y squared. So therefore we know the fact that x squared plus y squared, which is what we want, can be represented in terms of m and n, which is going to be m squared minus 2n. So that's how you would solve this question. So now we're going to do number patterns, right? So we're going to do question 2. It says consider the arithmetic sequence, which is x minus 3, 2x plus 1, 4x minus 1. They say determine the value of x. So I'm going to write the sequence. We know the fact that it's arithmetic, meaning it has a common difference. So we know the fact that x minus 3, right, is to 2x plus 1, and it's going to be 4x minus 1. We know that their difference, which is going to be this term minus this term, is going to be equals to this term minus this term. So we know the fact that the following, we know the fact that this term, right, minus the one in front of it, which is going to be 4x. So let me just do this. Okay, cool, doesn't want to go back. So if we say 4x minus 1 minus, then it's going to be 2x plus 1, right, is going to be equals to this 2, which is going to be 2x plus 1 minus, then it's going to be x minus 3. The reason why they equals to each other is because of an arithmetic sequence. He has a common difference. Hope that makes sense. So we're going to solve for x taking this, right? So we're going to solve for x from here. So now let's distribute the negative. So it's going to be 2x plus 1 minus x plus 3. Then on the other side, it's going to be 4x minus 1 minus 2x. It's going to be minus 1, right? So now we're going to basically clean up each side, right? So when we clean up each side, let's see the common terms. So we see the fact that this and this is common, we say this and this is common, and also on the other side we see this and this is common, then this and this is common, right? So we see the fact that this side 2x minus 1 is going to give me x, so it's going to be just x, and 1 plus 3 is going to give me 4, so it's going to be plus 4. Then this side is going to be positive 2x, and it's going to be minus 2, right? So we're going to take everything with x to one side and everything with a number to the other side, so it's going to be x minus 2x is equals to negative 2 minus 4, right? So this side we're going to have minus x is equals to minus 6. So therefore, since both of them are negative, it's going to be x is going to be equal. So therefore, x is going to be equals to positive 6. So that's how you're going to solve for x here. So now we're going to do 2.1.2. It says calculate the numerical value of the 7 terms. So we need to look for T7. So we want to solve for T7, right? So that's what we're looking for. So let me just write it here. So here we're basically looking for T7. So we're going to use Tn, right? So we know that Tn of an arithmetic is A plus open bracket n minus 1. Then it's going to be D. So to solve for T7, we know that n, right? You see the fact that 7 is here, meaning n is 7. So we know that n is 7. We need A. So we see that A is the first term. So in our case, the first term is this one. The first term is this one, which is x minus 3, right? So it's going to be x minus 3. So x minus 3, which is the same as, we know that x is 6. So it's going to be 6 minus 3. So we know the fact that the first term, right, is equals to 3. So it's going to be equals to 3. So we know the fact that basically A is equals to positive 3. Right? Then we need D, right? So D is going to be equals to, I said the fact that this is the common difference, right? You see the fact that this is what D is equals to, right? Or you can use this one, right? Because this and this is the same thing. So I'm going to take this one, right, to find D. So I know that D is going to be what? It's going to be 2x plus 1. So it's going to be 2x plus 1. So it's going to be 2x plus 1 minus, it's going to be x minus 3. So it's going to be minus x minus 3, right? So we know the fact that our x is equals to 6. So we're going to substitute 6. So it's going to be, substitute 6. So it's going to be 6 minus 3. Punch this whole thing in the calculator. You're going to get that our common difference is going to be what? Our common difference is going to be equals to 10. So our common difference is going to be equals to 10. So knowing the fact that, let me just highlight them. We know the fact that n is 7, A is 3, then D is 10. So now let's substitute. So we know the fact that now we're going to be looking for what? So let me just put this inside a block. We're looking for T7, right? So now we know the fact that T7 is equals to what? Is equals to A. A is 3, so it's going to be 3 plus n is 7, so it's going to be 7 minus 1, then D is 10, right? So punch this whole thing into your calculator. You're going to find that T7 is equals to what? Is equals to 63. And that's how you would solve this question. So now we're going to do 2.2, right? It says consider the quadratic sequence then they gave us. Then I'm always going to start with the one that wants Tn because it's going to be easy to solve for this one, right? Because we're just looking for the fifth term using this Tn, right? So the 2.2.2 says determine the n term of the sequence, which is we're looking for Tn. So we're looking for Tn. So I'm going to start with 2.2, right? So, and in the test, you are allowed to do that. You are allowed to start with any question that you want. Hope that makes sense, right? So doing 2.2, we know the fact that 2.2.2. So we see the fact that we have 2, we have 7, we have 16, we have 29, and it continues, right? So we know the fact that to find the first difference, it's going to be 29, right? So it's going to be 29 minus 16, which is going to give me 13. Then here, when you say 16 minus 7, it's going to be 9. Then when you say 7 minus 2, it's going to give me 5. Then to find the second difference, when you say 13 minus 9, you're going to get 4. And when you say 9 minus 5, you're going to get 4. Right? So we're looking for Tn. So what is important is going to be this side. Right? This is going to be what's important. So that's what's important to us, right? Because this is going to be equals to 2a, which we're solving for a. This is going to be equals to 3a. Ooh. It's going to be equals to 3a plus b. So we're going to be solving for b. Then here's equals to a plus b plus c, right? And remember that Tn for the quadratic is an squared plus bn plus c, right? So now let's solve. So we know the fact that 2a is equals to 4, right? So 2a is equals to 4. So therefore a is equals to what? Is equals to 2, right? So that's what our a is going to be. Then we know the fact that 3a plus b is equals to 5. So substitute 2's a, so it's going to be 2 plus b is equals to 5. So let's go up, right? So we can clean it up. So we know the fact that this is going to be 6 plus b is equals to 5. So therefore b is equals to 5 minus 6. So therefore b is equals to -1. Right? So b is going to be equals to -1. So c now it's going to be a plus b. So a plus b plus c is equals to 2. So we know that a is 2. We know that b is -1. And c is what we're looking for. So when you say 2 minus 1 is going to give me 1 plus c is equals to 2. So therefore c is equals to 2 minus 1. So c is equals to 1, positive 1. So therefore we know that Tn, right, is equals to what? Is equals to, our a is 2. So it's going to be 2n squared minus n. Then it's going to be plus 1. So that's going to be your Tn, right? So that's how you find your Tn. So now circling back to 2.2.1 is that we need to find T5, right? So this is what you're going to punch in your calculator. So you're going to have 2n, right? So we're going to have 2n. So n is going to be 5, right? So it's going to be 5 all squared minus, then this is going to be 5, and this is going to be plus 1. Right? So therefore, our T5 is going to be, when you punch that into the calculator, you're going to see the fact that T5, right, is going to be 46, right? So this you're going to cancel. So this is going to be what you're going to cancel in your, this you're going to do it in pencil. And this is basically your final answer. When you write T5 is equals to 46, without even showing the working out, they're going to give you 1 mark. Hope that makes sense, right? So that's how you would do it. So now we're going to do 2.2.3. It says show that the sum of the first difference, very important, they're talking about the first difference, right, of the quadratic sequence is equals to Sn is equals to this. So they're looking for the sum of the sequence, this, right? So that's what we're going to take. I'm going to take that sequence. So they're looking for the first, so the first difference, the first difference, right, is what? It is this one, right? So this is the first difference. So 5, 9, 13. So 5, 9, 13 is the first difference. So it's going to be 5, 9, 13. We know that the common difference here is 4, right? So we know that the common difference is 4. So we know the fact that the first difference, this is what? This is an arithmetic. So Sn of the first difference, we know the fact that the formula is Sn is equals to n divided by 2. Then it's going to be 2a plus n minus 1, right? And d, which is the difference. So what do we need? We need a and d, because of we're looking for Sn. So we're going to leave n the way it is, right? So we know that our a is equals to the first term, which is going to be 5. And we know that d is equals to 4, right? Which is the common difference. So we know the fact that Sn is equals to n divided by 2. Then 2, then this is going to be 5 plus, then it's going to be n minus 1. And this is going to be 4. Then let's clean this up, right? So it's going to be Sn, right? So it's going to be Sn. So let's clean out the square bracket. So it's going to be what? It's going to be n divided by 2. Then this is going to give me 10. Then this is going to be plus 4n. And this is going to be minus 4. Then this is going to be, close your bracket, right? So we're going to add 4 and negative 4. So it's going to be Sn is equals to n divided by 2. Then inside the bracket now we're going to be left with what? We're going to left with 4n, right? 4n plus 6. Hope that makes sense, right? Now we're going to distribute n divided by 2. So it's going to be Sn is equals to n divided by 2 multiplied by 4n. So it's going to be n divided by 2 multiplied by 4n, right? And this is going to be plus n divided by 2 multiplied by 6. So this is the same as Sn is equals to numerator to numerator. So it's going to be 4n multiplied by n divided by 2. Then this is going to be 6n divided by 2. Clean this up. So it's going to be Sn is equals to 4n squared divided by 2. And this is going to be the same as 6n squared, right? So now we know the fact that 4 can divide by 2, 2 can divide by 4, which is going to give me 2, right? So this is going to be Sn is equals to what? Is equals to 2n squared. And here is going to be 3n, right? So we have proven that Sn is equals to 2n squared plus 3n, which is what we have now, right? So now we're going to do 2.2.4. It says if the sum of the first 40 terms in question 2.2.3 is equals to 3,320, that is as 40 is equals to that. Then they say which term in the quadratic, very important. So which term in the quadratic, sequence has a value of 3,322, right? So now we need a relationship between Sn, right, of the first difference and the quadratic formula. And we actually have a relationship. The relationship is that Tn plus 1 is equals to T1, right, plus Sn. So this is the relationship between Sn of the first difference and the quadratic function, right? So this Tn is from the quadratic. So this is from the quadratic sequence, and this is from the first difference. So this is the Sn from the first difference. So we have a relationship between the two, right? So let me just put this, because we're going to use that relationship to calculate the value of the term. So let's make it in red, right? So now since we know the relationship, right? Since we know this relationship, we see something, right? And I'm going to give you what they gave us. They gave us that S40, right, is equals to what? Is equals to 3,320. And also we know that T1 from the quadratic formula is equals to 2, right? So we know the fact that this is equals to 2, right? So we know that this is equals to 2. If I add those two together, meaning saying T1 plus S40, we see the fact that we're going to get 3,322, which is exactly what we have here, right? So that is great. Why I'm saying that is great, we know the fact that now to find this this Tn is that we already know what n is. Our n is 40, right? So to solve for this n plus 1, right? So to solve for the term, the quadratic term, so solving for the quadratic term, solving the quadratic term, so solving the quadratic term, right? We know that the quadratic term is n plus 1, right? N plus 1, right? So we already know that n is equals to 40 from here, right? Because we know the fact that when we add this, 2 gets really this, which solidifies from this. Hope that makes sense, okay? So we know that n is equals to 40. So therefore, we know that n plus 1 is basically equals to 40 plus 1, which is equals to 41. So therefore, right, the the nth term, right, is equals to 41. So this is going to be your final answer for this question. Hope that makes sense, right? So now we're going to do 3.1. It says determine the number of values in the following geometric sequence, right? So we're looking for this. How many terms are there? Meaning we're going to use this, right? So this is going to be our Tn, right? And we're looking for n. How many terms are there, right? So hope that makes sense. So we know the fact that Tn of a geometric is equals to a multiplied by r n minus 1, right? So we need a and we need r, so we can solve for n, right? So now we know that a is equals to the first term, which is going to be 1 over 2. And we know that r is equals to T2 divided by T1, right? So now we know the fact that T2 is this one, then T1 is this one. So T2 is going to be the same as root 3 over 2 divided. So this division sign is going to be divided by 1 over 2. So now let's simplify it. So root 3 divided by 2. When you multiply, we're going to swap them. So it's going to be 2 divided by 1. So this is the same as what? This is the same as 2 root 3 divided by 2. And therefore, our answer is going to be root 3. So our common ratio is root 3. Hope that makes sense, right? So now substituting. So we know the fact that Tn is equals to 81 root 3 divided by what? Divided by 2 is equals to our a. It's a half, so it's 1 over 2. Then r is root 3. Then this is going to be n minus 1. So now what we want to do is we want to get rid of this half so we can have this alone on the other side. So we can solve for n. So it's going to be 81 root 3, right, divided by 2. Since it's multiplying, so it's going to divide by 1 over 2 is equals to root 3. And it's going to be n minus 1. So now let's clean this up. It's going to be 81 root 3 divided by 2. Then this is going to be multiply, so swap it. So it's going to be what? It's going to be 2 divided by 1. So this is the same as 81, right, multiplied by 2 root 3. Then this is going to be divided by 2 is equals to what? So this is going to be root 3 n minus 1, root 3 n minus 1. I was just focusing on this side too much. So the 2's are going to cancel out. So it's going to be 81 root 3, right, is equals to, then it's going to be root 3, then it's going to be n minus 1. So we see the fact that this, we can use the log rule, right? So using using the log rule, meaning this is going to be what? This is going to be on the other equal sign. This is going to be our base, since our base, and this is going to be on the other side. So this is going to be n minus 1 is equals to log, then our base is going to be root 3, then here is going to be 81 root 3, right? So you're going to punch this into the calculator, right? So when you punch that into the calculator, you're going to find that n minus 1 is equals to 9, right? So take the 1 to the other side. Therefore, n is going to be equals to what? It's going to be equals to 10. So our n is going to be equals to 10. So now we're going to do 3.2, right? It says solve P such that then they give us this, right? So they tell us this side, the summing to infinity is equals to this. So if we zoom it in, is that our P is here, and they tell us where P lies, right? P needs to lie between -1 and 1. Reason is that we're looking for summing for infinity, which makes sense for this restriction, right? Our radius, which is in our case, our radius is P, needs to lie for this 2 so that we can have the sum to infinity. So what we need to do is that both the left hand side and the right hand side, we need to write them in a form of Sn, right? In the Sn formula, so that we can simplify it, right? So let's do that. So I'm going to name this the left hand side and this the right hand side. Right? So looking at the left hand side, we know that the left hand side is equals to the summation from infinity when k is equals to 0 of 9. And this is P, then this is K, right? So we know the fact that the S to infinity is equals to A divided by what? Divided by 1 minus R. So we need A and we need R. So what is A? So A is equals to the first term. So A is equals to when K is equals to 0. So here, when K is equals to 0, so here we're going to substitute when K is equals to 0, and that's going to be our A, right? So it's going to be N, and this is going to be P, then to the power 0, right? Hope that makes sense. So therefore, our A is equals to 9, right? Multiplied by what? Multiplied by anything to the power 0 is equals to 1. So therefore, A is equals to 9. Hope that makes sense, right? So now we're looking for R. So we know that R is equals to what? It's equals to T1, what you call this, T2 divided by T1. But now we see the fact that here we're starting where? We're starting at T0. So it's going to be from T1 divided by T0, right? Hope that makes sense. So with that said, is that we already know that T1 is equals to A. So we know the fact that T0 is equals to A, which is equals to 9, right? So now we're looking for what? We're looking for, okay, let me just do this. Just further down. Yeah. So let me just take this one here. Yes. Right. So now we're looking for T1. So we know the fact that T1, right, is equals to what? Is equals to 9. Then it's going to be P. Then it's going to be 1. So therefore, this is going to be 9P, right? So this is going to be equals to what? From here, it's going to be T1, which is going to be 9P divided by what? Divided by 9. So our R is basically equals to P, which makes sense when I started explaining the fact that our P is technically our R, right? So we have our R and P. So we know the fact that S infinity, right, is equals to what? It's basically equals to, it's basically equals to A. A is 9, so it's going to be 9 divided by 1 minus P, because that's R. So we have written our S infinity in this form. So let me just pull it up and take it here, and I'm just going to put it inside a block. Right, I'm going to put it inside a block. We're going to revisit it, right? Maybe let's do it in blue. Right? So we know that our left hand side now is equals to that, right? So maybe let's color coordinate. I'm going to highlight this in blue. So we know the fact that this side is equals to that, right? Now we're going to do the right hand side. So let me go up. So our right hand side is equals to what? It's equals to the following. It's the summation, right? It's the summation. So it's the summation, right? And it's 7. Then it's M is equals to 1. Then it's going to be negative 27. Then this is going to be negative 2 over 3. Then it's going to be M, right? So now we need to basically find the sum of this, right? Change this into SN, right? Using SN. But very important is SN has two formulas, right? So with geometric, right? It has two formulas. Is that we know that SN can be equals to what? It can be equals to when A, then it's going to be R to the power N minus 1. Then it's going to be divided by R minus 1, right? And this is when R, right? R is greater than what? Greater than 1. Hope that makes sense, right? It's when R is greater than 1, meaning any number 2, 3, 4, 5, then we use this formula. But we have another formula when Sn is equals to A open bracket 1 minus R to the power N, right? Divided by 1 minus R. And this is when R is between what? Is between negative 1 and 1. So this is when R is like between negative 1 and 1, right? So first, to determine which formula is that we need to basically determine which Sn we're going to use. And how to do that is to find R. So finding R, put this inside a block. So we need to find R first, right? Finding R. Finding what is R. What is R, right? So we know the fact that R is equals to T In our case, since we're starting with 1, right? So meaning it's going to be the number after it. So it's going to be T2 minus T1. So it's going to be T2 divided by T1. And just go back. I want to cycle back, right? That is why here it was T0. So since it starts at k is equals to 0, so to find r is going to be the number after 0. So it's going to be T1 divided by T0. Hope that makes sense, right? So we know the fact that that's going to be that. So now finding T1, right? So finding T1, we know that T1, right, from here is going to be what? It's going to be wherever we see M, right, we're going to put 1. So it's going to be negative 27, right? And this is going to be negative 2 over 3. Then this is going to be to the power 1, right? So we're going to have that. I'm going to leave that like that. Then we see the fact that T2 is going to be negative 27. And it's going to be minus 2 over 3. And it's going to be 2. I'm just going to leave them like that, right? So now let's substitute. We know that r is going to be equals to what? It's going to be equals to negative 27. And it's going to be negative 2 over 3. Then it's going to be 2. Then this whole thing, right, is going to be negative 27. It's going to be negative 2 over 3. Then it's going to be 1. We see that this and this are going to cancel out. So you're going to have r is equals to, so it's going to be negative 2. Sorry, let me just do this. It's going to be minus 2 over 3. So it's going to be minus 2 over 3. Then it's going to be 2 divided by negative 2 over 3. Then it's going to be 1. Since it's the common base, right, so we can subtract the exponent. So it's going to be negative 2 over 3. Then it's going to be 2 minus 1. Therefore, r is going to be negative 2 over 3. It's going to be what? It's going to be positive 1. So this is going to be r. So we know that our r is that, right? And we see the fact that we also need a. So we see the fact that a, this is also equals to a, right? So this is also equals to a. So basically, yes, this is also equals to a. So this one is also equals to a because that's our first term, because we started at m is equals to what is equals to this. So we know the fact that our r is negative 2 over 3. And when we find decimals, this is going to be definitely between this. So the Sn that we're going to use is that one. So we know that Sn is equals to okay, cool. So we have r, we have a, then we need what? We need n, right? So n is going to be equals to what? Our n is going to be equals to the top value, right, minus the bottom value plus 1, right? So it's going to be the top value. So it's going to be top minus bottom plus 1, right? So this is going to be n. Top value is 7 minus the bottom is 1. That's going to be plus 1. So therefore n is equals to 7. Hope that makes sense. So let's highlight everything that we have. So we know the fact that this, we need r, we need n, and lastly we need a. So this is going to be a. Right, so we know the fact that from r we need to use the second formula. So we know that Sn is equals to what? To a, open bracket, 1 minus r to the power n, and this is divided by 1 minus r. Hope that makes sense, right? So now we're going to substitute everything that we have, right? So we're going to substitute everything that we have. So when we substitute, we're going to have the following. So we know the fact that it's going to be S7. So it's going to be S7, right? S7 is equals to, what is our A? Our A, we see the fact that it's going to be negative 27. It's going to be negative 2 over 3, right? Then open bracket is 1 minus, then our r is going to be negative 2 over 3, then to the power 7, and this whole thing is divided by, so now the denominator is going to be 1 minus, that's going to be negative 2 over 3, right? So now what we're going to do is that we're going to clean up this, we're going to clean up this, and we're going to clean up this, right? So let's do that. So it's going to be S7, and this is going to give me 18, right? Then this is going to give me 1 minus, then this is going to give me minus 128 divided by 2187, right? Then the denominator is going to be the same as 1 plus 2 over 3, right? So now let's clean it up further. So we're going to clean up the bracket and the denominator. So S7 is equals to 18. So inside the bracket, we're going to have what? We're going to have 1 plus 128 divided by 2187. And the denominator, we're going to have it as 5 over 3, right? So now you can basically punch this whole thing into the calculator. So when you punch in the whole thing inside the calculator, you're going to find that S7 is technically, right, is equals to what? It's equals to 926 divided by 81. So that's S7, right? But we know the fact that S7, right, from the question is that this is the same as S7 is equals to, so this is the same as S infinity is equals to S7, right? Because this, and maybe let's highlight it. Maybe let's make it in purple. No. So yes, we know the fact that this is technically what we just solved here is equals to this, right? So we see the fact that it's the blue one, which is equals to the blue, is the blue one, which is equals to the purple one, right? Hope I'm making sense. So we know the fact that blue is equals to purple. So let me delete this. I wanna have consistency. We know that blue is equals to purple. So let's equate them, right? So we know the fact that the blue one, we're gonna copy and paste it here, is equals to the purple one. So we know the fact that blue one, right, is equals to, so it's equals to what? It's equals to the purple one. Yes, I want to copy and paste this, duplicate, cut. So we know that this is what we have, right? So now with that said is that we can solve for P because P is going to be the only unknown. So if I say 9 divided by 1 minus P is equals to 926 divided by 81. I can cross multiply. So 81 multiplied by 9 is equals to 926, right? And it's going to be 1 minus P, right? So we're going to have that. So we know the fact that this is going to give me 729 is equals to, then it's going to be 926, right? Minus 926 P, right? So we're going to take everything without the P to one side. So this is going to be the same as 729, right? Minus 926 is equals to minus 926 P, right? So subtracting one side together. So we see the fact that this we're going to get minus what? Minus 197, right? Is equals to what? Is equals to negative 926P. So solving for P, we know the fact that 197 divided by negative 926 is equals to P, right? So we know the fact that therefore P is equals to negative 197 divided by, so positive. So this is a positive, so it's going to be 197 divided by 926, right? And we see the fact that if we get this into a decimal, P is basically equals to 0.21, which is definitely between what? Which is definitely between, P is between -1 and 1. So now we're going to do functions, right? So we're going to do question 4. Let's read the question. It says the graph f of x is equals to a half x plus p all squared plus q, right? So this is a what? This is a, let me just go back. Okay, cool. So let me just go back. Okay, let me just position it back again. So we see the fact that this is a quadratic function and g of x is a hyperbola. So the quadratic has p and q missing, which is the turning point, and g of x has a, r, and t, where r and t are your asymptote are missing. So we need to find that probably in the question. Then we have h of x, which this is what a linear function, but they tell us the very important thing that this is what the axis of symmetry, right, of G. So this is the negative axis of symmetry of what you call this, of G of x, which is this one. Then they tell us C is the y-intercept for both G of x and h of x. So meaning C here is the y-intercept of this linear function and also this hyperbola. Hope that makes sense, right? And they tell us that E is the turning point. So since E is the turning point, we see the fact that they gave us P, right? They gave us P here. Do you see the fact that this x-intercept is our P, but the opposite sign. Meaning here, our P is what? So let me just put it here. Meaning our P here is equals to positive 2, right? Then we see the fact that W is, this is W, Q is W. Hope that makes sense. Then they tell us the fact that a point on F, and they tell us the fact that the point of intersection of the asymptote at G. So we see the fact that point B, right? So let me just do this. Yes. We see the fact that point B here is the point of intersection of the asymptote of the graph G. Hope that made sense. So now let's answer the first question. It says, write down the coordinate of C. So C is here, right? We see the fact that C is the y-intercept of the graph h of x and also g of x. But the nice thing is that from h of x, so we see the fact that C is the y-intercept of both g of x and h of x. But h of x, right, we have it as what? We have it as equals to negative x plus 3. So this is your y-intercept. So therefore, coordinate C is 0 is to 3. And that's how you would solve this question. So now we're going to do question 4.2. It says, shows that the coordinate of B, which is here, right, is equals to 2 is to 1. So what do we see? We see the fact that we have a line, right? We have a line going through from C, then it goes through B, then it goes through A. B is what? The coordinate B is the intersection of the asymptote of this line, right? Of these two lines, the axis of the asymptote of the graph G of x. So how this is important is that if we have a line, because we know the fact that angle H, like not angle H, we know that H, the line H, right, is the axis of, what you call this, is the axis of symmetry of the graph G of x. And since it's always gonna pass through what the axis of symmetry, right, the point where it intersects, is that the distance. So we know the fact that, okay, cool, maybe let me just show you what's happening. So we have a graph, right, and I'm just gonna erase it. So we have a graph here, I'm just gonna erase it, and we have our graph, and in our graph is that our asymptote, this is our asymptote. So let me just go with this. We know the fact that this is our asymptote. I want to emphasize something, right? Within our asymptote, let me go back to solid, and let's say our graph is like this, right? So this point here, right, which is in our case is B, right? This point is the intersection of our asymptote, our dotted lines. We know that, right? And then we have two lines of axis of symmetry. We have a line that goes like this, goes like this. Let me go back. Okay, go. We have a line going like this. So like this, right? So the axis of symmetry means the fact that this point, whatever the point that's here and here, it's going to be exactly what you call this. It's going to be like identical, basically. What I mean is that the distance from here, right, to here is going to be identical. But we have this one, which is the one with the negative, with the positive. So this is why it's equals to that. This is from the negative, so it's negative x plus c. This is the equation of the symmetry. Then we have another one, right? This is the one with the negative gradient. That's what I meant. Then we have another one, which is like this, right? Which in our case, this is the one that we have, right? And this is for the positive gradient for this graph. Hope that makes sense. So it's going to be x plus c. So this is the axis of symmetry for the positive gradient. We see the fact that that line passes through what? If that line passes through this, right? So meaning the distance between here and here and here and here is going to be the same. Meaning this point here, which is the intersection, is the midpoint between these 2 points. Taking that into the account is that's what's happening here, right? Since we know the fact that the line h of x, right, is the what? Since we know that the line h of x is the intersection, right? It's the not the intersections, it's the axis of symmetry of G, right? Since we know the fact that h of x is the axis of symmetry of G, that means the fact that the distance between here and here is going to be equal because that line passes through B, which is what we want. So meaning B is the midpoint. Hope I'm making sense. So we're going to use the midpoint theorem to basically the midpoint formula to solve for B. Hope I didn't confuse you guys, right? So first thing that we're going to state is the following. We know that, so we know the fact that h of x, so we know the fact that h of x, so we know that h of x, so we know that h of x is the what you call this, axis of symmetry. Symmetry, right, of G of x. That means, and also, no, and also B is the intersection, is the intersection of the asymptote of what? Asymptote of G of x, right? So since that line cuts through those two, right? Since h of x, so since h of x, right, cuts through point C, comma, B, and A, comma, and since, do you see the fact that they're on the same line, like they're on the same line, since it cuts here, here, and here, and where C and A are on the G of x, comma, where C and A is on G of x and h of x, right? That means, and we can draw, okay, cool, and okay, cool. and we can draw a line through all 3 points, comma, that means that B is the midpoint, of C and of line CA. Hope that makes sense. That was pretty long. But with that said, now we know that point C is 0 is to 3. So we know that point C is 0 is to 3. And A is given as 4 is to negative 4 is to negative 1, right? Then now using the midpoint theorem, so we know that midpoint is equals to what? Is equals to XC plus XA divided by 2 is to YC plus YA divided by 2. But we know that the midpoint in our case is point B is equals to, so this is going to be 0 plus 4 divided by 2 is to what? Is to 3 plus negative 1 divided by 2. So therefore point B is equals to what? Is equals to, punch that into the calculator, you're going to get it as 2 is to negative 1. And that's how you would prove that this is 2 is to positive 1. Sorry, it's going to be, this is going to be negative, so it's going to be positive 1. Made a mistake there. So our answer is going to be 2 is to positive 1. So when you punch this into the calculator, you're going to get positive 1. When you punch this into the calculator, you're going to get positive 2, which matches up exactly to this, right? Just to recap for one more time, is that if you have a line that goes through all 3 points, and the most important point is this one, it goes through, right? Goes through the intersection of the asymptote, and also goes through here, which is point C and A, which is an intersection of the g of x, which is the hyperbola, and also the axis of symmetry, and same thing, and that line goes through, connects all 3 points, then you can basically say the fact that B is the midpoint. Hope I'm making sense, right? Because the side here is equals to the side as I did it in this diagram. Hope I'm making sense, Anna. Now we're going to do 4.3. It says determine the value of A, R, and T. So let's check where A, R, and T is from. So go back to the question. It's from g of x. So we see the fact that g of x is equals to what? We see the fact that g of x is equals to A divided by x plus r. So it's going to be x plus r plus t, right? Then we know that from 4.2, right, we solved that. We know that for 4.2, we know the fact that we found point B, and point B was what? Was 2 is to 1. 2 is to 1, right? So this is the point of intersection, meaning this is going to solve for our r. Our x coordinate always is opposite the sign. Since here is positive, meaning our r is the opposite sign. So meaning r is the opposite sign, meaning r is going to be equals to negative 2. Then t in our case, which is going to be this one, right, is going to be what? It's going to maintain a sign, so that t is equals to 1. So now let's update g of x. So it's going to be g of x is equals to A divided by what? X minus 2 plus 1. Right, now we need to solve for A. So to solve for A, we see the fact that from the diagram, we given the fact that this point A here, we can substitute this point to solve for A, right? So we're going to substitute point A, which is going to be what? Remember the fact that it's 4 is to negative 4. 4 is to negative 1 into g of x to solve for a, right? So we know the fact that this is going to be -1 is equals to a divided by 4 minus 2 plus 1, right? So this is going to be -1 is equals to a, and this is going to be +2, then it's going to be +1. Take the 1 to the other side, it's going to be -1. -1 is equals to a divided by 2. It's going to be -2 is equals to a divided by 2. So when you say -2 multiplied by 2, you're going to get a. So therefore, a is going to be equals to -4. Right, so we have solved our equation in terms of solving a. We know that a is -4. Then r and what you call this, r and t is equals to -2, and t is equals to 1. So therefore we can say a is equals to -4, r is equals to -2, and lastly t is equals to +1. And that's how you would solve this question. So now we're going to do 4.4. It says determine the equation of asymptote of j if j of x is equals to j plus, then it's going to be x plus 3 minus what? -1. So first, let's find the asymptote of what? The asymptote of j of, of g of x. So asymptote of what? Of g of x, right? We see the fact that that is going to be y is equals to, so let's start with x because I need order, right? We see that x is going to be equals to, do you see coordinate b? So let's go to coordinate b, right? So coordinate b, so let me just do this, right? So from point B, which is the intersection, right? Which is from point B is the intersection, which is 2 is to 1. Or you can go to g of x. Remember the fact that when we were looking at g of x from here, you can pick from point B because point B is the easiest in our case, right? So from point B, we see the fact that this point B is the intersection, right? Is the intersection of the asymptote. Right? So meaning our first asymptote is going to be x is equals to always the opposite sign. No, not always the opposite sign. In our case, since it's the coordinate straight, so x is going to be equals to exactly 2 and y is going to be equals to 1, right? So that's that. Then for j of x, so we see the fact that j of x is equals to g, then it's going to be x plus 3, then it's going to be -1. This one, do you see this one is going to affect, is going to affect x, and this one is going to affect y. Hope that makes sense, right? So now for this one is that x is going to be equals to 2 plus what? 2 plus this one. Since this one, do you see the fact that it's inside the bracket? Since inside the bracket it's positive, here outside is going to be negative, so it's going to be -3. And let's color coordinate it so that it makes sense. So we see the fact that here, it's here, opposite side, right? And y is equals to, we see the fact that it's 1 plus this one. So it's going to be 1 plus this one. So exactly the sign it is, so it's going to be -1. So it's going to be this one, right? Hope that makes sense, right? So everything is sorted. Now let's clean it up. So when we clean it up, that's going to be x is equals to 2 minus 3 is going to give me minus 1. And this one is going to be y is equals to what? Is equals to 0. So that is going to be your asymptote for j of x. Hope that makes sense, Anna. So now we're going to do 4.5. It says show that the equation of f is given as this, right? So let's take the original f of x. So the original f of x, right? So if we go up, the original f of x, let's go up. Remember, it's this one, and we already know what p is, so we're going to substitute p. So the original f of x is that. So we know the fact that f of x, right? So f of x is equals to what? Is equals to a half. Then open bracket is going to be x plus p all squared, right? Plus q, right? So that's the original. But, right, we were given that the turning point is this point here, which is E, which is negative 2 is 2w. Remember, we were given that. So therefore, so we know the fact that this is going to be what? This is going to be our p, but opposite sign. So since it's outside is the coordinate, so meaning p is going to be equals to positive 2 since it's negative here. So meaning our f of x is equals to 1 over 2. Then this is going to be x plus 2 all squared plus q. So right now is that we need to find what q is, right? So if we go back, we see that our graph cuts through point B, right? So we're going to substitute B to find Q, right? So we're going to substitute B. So what we're going to do is that we're going to substitute point B, which is 2 is to 1, to solve for Q. So now let's do that, right? So it's going to be what? It's going to be 1 is equals to what? Is equals to a half. Then this is going to be 2 plus 2 all squared plus q, right? So now we're solving for what? We're solving for q. So it's going to be 1 is equals to what? It's going to be 1 over 2. And this side is going to be 4. Then it's going to be all squared plus q. It's going to be 1 is equals to 1 over 2. And we're going to have 16 plus q. Then it's going to be 1 is equals to, then a half multiplied by 16. It's going to give me 8 plus q. Take the 8 to the other side. So it's going to be 1 minus 8 is equals to q. So therefore, q is equals to what? Is equals to negative 7, right? But remember the fact that we needed, in terms of f of x, we need to expand it, right? So let me just do this. We need to expand this, right? We need to basically expand this so that it can look like this. So now let's update our f of x. So our f of x now is equals to a half. Then it's going to be x plus 2 all squared, right? And it's going to be minus 7. So now let's expand this. So f of x is equals to a half. It's going to be x squared, right? We're going to expand the bracket, x squared plus 4x plus 4. Then it's going to be minus 7. So therefore, f of x, we're going to distribute the negative. So it's going to be negative a half, right? Squared. So it's going to be negative a half squared, right? Then it's going to be plus 2x. Then it's going to be plus 2. It's going to be minus 7. So now this is going to be f of x is equals to a half x squared plus 2x. And this is going to be minus 5. So let's check, is it exactly what they want? Yes, it's exactly. So this solves this question. So now we're going to do 4.6. 4.6 is exactly one of the questions that I did in the Free State paper, right? Where it's 5.3. I will leave a link to that question. Where in this question, they said the fact that determine the values of k such that f of x is equals to k when it's two positive roots. In this question now, so now in this question is the same thing. It's f of x, right, is equals to k. We need to determine the values of k for two negative roots. Do you see it's the same thing, but here's positive and here is negative. So the framework is the same, right? But the thing that's going to change is going to be one of the conditions. Hope I'm making sense. So we're going to use this framework, right, to basically solve for this question, right? So from this one, do you see the fact that the first thing that we need to do is that we need to write it in standard form, right, which we need to do that side. And after writing in standard form, we need to solve for this. Then equal roots means this, meaning we're going to find the first boundary using that, right? Then finding the second boundary, I'm not going to use the sum, right? The sum is basically to check whether it's positive, and you'll see the fact that it's positive. But we need the second boundary, which is we're going to use the, we're going to use the product roots, right? So that's going to give me the second boundary. Then we're going to basically find it. So now let's do this one, right? So the first one is that we need to write it in standard form. We see the fact that it's f of x. So we have that f of x, right? So number one is that we need to do f of x is equals to k, write it in standard form. So we see the fact that f of x in our case is equals to what? Our f of x. So we see the fact that our f of x is equals to a half. Then it's going to be x squared plus 2x, right, minus 5 is equals to k. Write it in such a way that the other side is 0. So this is going to be a half x squared plus 2x minus 5, and it's going to be minus k is equals to 0. So I'm going to pull out the negative this side. So it's going to be a half. This is going to be a. Then b is going to be 2x. Then here I'm going to pull out the negative. So it's going to be minus. It's going to be 5, right? Minus plus k. Or you can just leave it like this, but I just like writing it like this, right? Now, after writing it in standard form is that we're going to find the first boundary. They tell us the fact that in the equation they want what? They want our two terms to be negative, right? So it's equal, it's two unequal terms. So it's going to be this one. So this is going to give us our first boundary. Do you see? This is going to give us our first boundary, right? And this one, do you see the fact that the product, this one is going to give us the second boundary. So now finding the first boundary. So finding the first boundary. So the first boundary, so I'm going to say first boundary. Right, so it's going to be for the first boundary. It's going to be first finding the triangle, right? So we know that the triangle is going to be b squared minus 4ac. Right? So it's going to be b squared minus 4ac. So we know the fact that our a is equals to a half, our b is equals to 2, and lastly c is equals to, let me say negative 5 minus k, or you can just write this. Hope that makes sense, right? So that is basically what? That is going to be our a, b, and c. So now solving for the triangle is going to be 2 all squared minus 4, then it's going to be a is a half, then c is going to be minus 5 minus k, right? So simplify this. So it's going to be the triangle is equals to 4, right? 4, then this is going to be minus. So this is going to be 2, then it's going to be minus 5 minus k. So distribute the negative 2. So the triangle is basically equals to what? It's equals to 4 plus 10 plus 2k. So clean this up. It's going to be the triangle is equals to 14 plus 2k. Hope that makes sense. So, but we know the fact that the boundary says two unequal roots. So meaning it's going to be the triangle is less than. So we're solving for this is less than, right? So we know the fact that the triangle less than is the same as 14. The triangle is equals to 14, right? Plus 2k is less than 0. Right, so solve for k here, which is going to create the same the first boundary. So it's going to be 2k less than, take the 14 to the other side, it's going to be negative 14. Therefore k is less than, then when you say 14 divided by what? 14, negative 14 divided by 2, therefore k is less than negative 7. So this is the first boundary, right? So now the second boundary, right? So the second boundary, you always ignore what? You always ignore the sum. The sum part doesn't matter. It's just verifying. This gives us the second boundary. Hope I'm making sense, right? So the sum, right? So we always calculate the product of the what? The product of the sum. But in our case, the product of the roots is what? Is less than. Is less than 0. This is for negative root. Hope that makes sense. So second boundary, so finding the second boundary. Second boundary. You can ignore the sum, right? So the second boundary is we ignoring the sum. So the product of the root needs to be what? Needs to be less than 0. So it needs to be less than 0. So the product of the roots, the formula, product of the roots, it's equals to, go up, it's equals to C divided by A. So it's going to be C divided by A. So we know the fact that our C is what? Is negative 5, negative K. So we know the fact that this is going to be negative 5, negative K, right? So it's going to be negative 5, negative K divided by what? Divided by A, which is a half, right? Which is our A is a half. A is a half, so it's going to be a half, right? So now let's clean this up. This is the same as negative 5, negative K, right? So this whole thing divided by 1 over 2. So change this into multiplication. So this is going to be negative 5, negative K, multiply, swap. So it's going to be 2 divided by 1. So this is going to swap when we change it to multiplication. So this is the same as negative 5, negative K, multiplied by 2, right? Multiply throughout, so it's going to be negative 10K, negative 10, sorry, minus 2K, right? So we have the product. So we know that the product needs to be what? If we go back, it needs to be for negative roots. Do you see here? It needs to be greater than 0. So the product needs to be greater than 0. So we know that the product, so it's going to be the product. So we know that the product of the roots to be greater than 0, so it's just negative 10, negative 2K needs to be greater than 0. So it's going to be negative 2K greater than, take the 10 to the other side, it's going to be 10, divide both sides by 2, so it's going to be K. Since it's negative 2, the inequality sign is going to change, so it's going to be 10 divided by negative 2, so therefore K divided by negative 2, so therefore K is going to be what you call this, less than negative 5, right? So we have that. So now our K needs to be what? This is going to be negative 5, and on the other side, which is this one, it's going to be negative 7. So it's going to be negative 7, and that's going to be your inequality. Hope that makes sense, Anna. So now we're going to do 4.7. Actually, 4.7 is also using the same framework, right? So I'm going to read the question. So to show you the fact that it uses the same framework, it says determine the value of D, right? Such that, then they gave you this, that will have 1 positive and 1 negative. It uses this framework. Do you see the fact that this framework is that obviously you're going to have unequal roots. So it's always going to be unequal roots. But we have 3 conditions. You have if they are both positive, which is this one. Remember that this one is for both positive, then both negative is the one that we just did previously, then 1 negative and 1 positive is going to be this one. So we're going to use this one to solve it, right? So we're going to use this one, which, remember the fact that to find our boundaries, the first boundary is going to be always what? Our first boundary is going to be calculating this, then the second boundary is going to be using the product rule, which in our case, using the product rule is going to be less than 0 if we want opposite signs. Hope that makes sense, right? So first thing first is that we need to write this in a form of ax, ax squared. So we need to write it in this form, in the standard form. Reason is that we need a, b, and c, right? So that's what we're going to do. So step number 1 is that we're going to write it in the standard form. So we're going to write this in the standard form. So write this in the standard form. So we're going to write in the standard form, which is in our standard form is ax squared plus bx plus c is equals to 0. That is the standard form, right? So we have a half, and it's going to be x plus d all squared plus 2ax plus d. That's going to be minus 5 is equals to negative. That's going to be x plus d plus 3. So we now need to write this in the standard form, right? So now let's expand, right? So the first one is going to be what? It's going to be a half. That's going to be x squared plus 2xd plus d squared, right? And this is going to be plus 2x. That's going to be plus 2d minus 5 is equals to negative x minus d. Then this is going to be plus 3. Clean it up a little bit further, right? So when we clean it up, we're going to distribute the half inside. So when we distribute the half inside, we're going to have a half x squared, right? Then it's going to be plus xd. Then it's going to be plus a half d squared. Then it's going to be 2x. Then it's going to be plus 2d minus 5 is equals to minus x minus d plus 3, right? Take everything to one side. So it's going to be a half x. So it's going to be a half x squared, right? And this is going to be plus xd. That's going to be plus a half d squared. Then this is going to be plus 2x plus 2d. That's going to be minus 5. And this is going to be plus x plus d minus 3 is equals to 0. Group like terms, right? So when we group like terms, so we're going to have this being alone, right? So this is going to be alone, but this, the ones that contain just x, so it's going to be this and this being together, right? Then the one that contains just, that doesn't have x, so it's going to be 1, 2, 3, the 3 together, right? So now let's group them. So we're going to have a half. So let me just clean this. Yes, so this one's going to be alone, so it's going to be a half x squared. Then it's going to be plus xd plus 2x. And it's going to be plus x, right? So I'm just going to put inside the bracket saying that they together. Then we're going to have plus a half d squared. Then it's going to be plus 2d. Then it's going to be minus 5. It's going to be minus 3 is equals to 0, right? So plus d again. I forgot a d here. So it's going to be plus that d. So it's going to be plus d is equals to 0, right? So this are all together, right? So now we're going to have what? We're going to have a half x squared. So now here we're going to pull out this x as a common factor, right? So if we pull out this first, before we pull out this x as a common factor, the ones that we can add together, we see the fact that we can add this two together, right? So this is the same as plus, this is going to be xd plus 3x, right? So we're going to clean this one up. We see the fact that we can add this two together and this two together. So this is the same as a half. So it's going to be a half d squared, right? And it's going to be plus 3d. Then it's going to be minus 8, right? Is equals to 0, right? So now we're going to pull out x here as a common factor. So this is going to be a half x squared. And this is going to be plus x. And this is going to be d plus 3. Then this is going to be plus, leave this alone the way it is. So it's going to be d squared plus 3d, right, minus 8 is equals to 0. Hope that makes sense, right? So reason why I pulled out this x, because this is the coefficient that we want, right? This whole thing is the coefficient. So now we know the fact that our a is equals to a half, a b is equals to d plus 3, then c is equals to a half d squared plus 3d minus 8. Hope that makes sense, right? So we have that, right? So now with that said, we can basically sort this out, right? So we know the fact that the second step is finding the first boundary. So finding the first boundary, it's using, finding the first boundary is the triangle unequal angle, which is this one, right? So first we need to solve for the triangle. So we know that the triangle is equals to b squared minus 4ac, right? So we know the fact that the triangle is equals to what? This is going to be b squared, which is going to be d plus 3, right? Minus o squared. And this is going to be 4. Then this is going to be, a is going to be a half. Then this is going to be a half. Then it's going to be d squared plus 3d minus 8, right? So now we're going to sort this out. So it's going to be d squared, right? Then it's going to be plus 6d. Then this is going to be plus 9. Then this is going to be minus. Then this is going to be 2. Then it's going to be plus a half d squared plus 3d. Then this is going to be minus 8. So now let's distribute negative 2. So it's going to be triangles equals to d squared plus 6d plus 9. Then there's going to be minus d squared. Then this is going to be minus 6d. Then it's going to be plus 16. Right? So we see the fact that if we group like terms, d and d are going to be together. Then the 6 and this negative 6 are going to be together. And lastly, the constant values, which is 9 and 16, are going to be together. So we're going to have that the triangle is equals to, the blue ones are going to cancel together because of, they're going to cancel each other because one is positive and the other one is negative. Same applies to the yellow ones. So we're going to be left with 9 plus 16. So if you say 9 plus 16, if you say 9 plus 16, you get 25. So you get that the triangle is equals to 25, which basically supports this. This is definitely, the triangle is definitely greater than 0, which is positive, right? So this didn't give us our boundary, but the second one is going to give us the boundary. So the second one, so the second boundary says what? We need to find, let's go back to this. We need to find when the product of the roots is what? Is less than 0. So that's what we're solving, right? Is we solving the, so this is going to be product of the root is less than 0, right? So let's find the product of the root. We know that the product of, so therefore this, we know the fact that it is less than 0. Yes, so product of the root is equals to c divided by a, right? So we know that our c from here is 1 over 2, so it's going to be 1 over 2 d squared, right? Plus 3 plus 3d plus 3d minus 8. So it's going to be minus 8, and that whole thing is divided by a half, right? It's going to be divided by a half. So we know the fact that this is basically going to be equals to what? This is going to be equals to 1 over 2 d squared plus 3d minus 8, and this is going to be divided by a half, right? This is the same as 1 over 2 d squared plus 3d, and it's going to be minus 8. Then this is going to be what? This is going to be multiplied, and this is going to be 2 divided by 1. So distributing, so this is the same as 1, right? So distributing it is going to be 2 multiplied by half, which is going to give me d squared. 2 multiplied by 3 is going to give me 6d. Then lastly, negative 8 divided by 2 is going to give me negative 16, right? So that's what I'm going to have. So now with that is that we're going to factorize this. So we know the fact that we're looking for what we're looking for. So we have everything in terms of the product of the roots like this, right? So we know the fact that the product of the roots, but therefore we know that the product of the roots, is less than 0. So we know that d squared plus 6d minus 16 is less than 0. So this is straight up inequality, right? So I'm going to bring up the inequality table. So now using the inequality table, right, we know the following. We know the fact that basically one is that instead of x, we're going to be dealing with with d, right? So let's assume the fact that the table was in terms of d, right? So that's the first thing. So now we see the fact that our equation is like this, where it's eating the 0. So let's highlight that one, right? The one that looks like it. It looks exactly like this one. Do you see? It looks like exactly like this one, right? So if that's the case, we need x1 and x2. So let's find x1 and x2, which in our case is going to be d1 and d2. So now let's do that. We see the fact that here, finding critical values, so finding CV, right? We know the fact that d squared plus 6d minus 16 is equals to 0. So now let's find the critical values. It's basically going to be d plus 8, right? And it's going to be d minus 2 is equals to 0. So let me go up. So we know the fact that d plus 8 is equals to 0, or it's going to be d minus 2 is equals to 0. Therefore, d is equals to either negative 8 or d is equals to positive 2. So the smallest one becomes x1, in our case is d1. So therefore, d1 is going to be equals to negative 8 and d2 is going to be equals to positive 2, right? Remember that our answer is d is an element. So d is an element. Remember the fact that here, it's x is an element between x1 and x2 curved bracket. In our case, it's going to be d is an element from d1 curved bracket and d2, right? So we know the fact that d is an element between where? Between negative 8 and 2. And that's going to be your final answer for this question. So now we're going to do question 5, right? It says the following. The graph f of x is equals to log, right? So this is the graph, which is, this is more or less the inverse of the exponential, but they gave you f of x in terms of the inverse, right? So it's going to be the log. Then they tell you the fact that k of x, which is this one, is the linear function, is drawn below. Then they tell you that point A, which is on the inverse function, right, is the point on f. And D is the x-intercept for both f and k, right? So now moving to point D, right? So if they give you the inverse, and maybe I'm going to give you the table again, right? Let me give you the table. So now we know that point D is the is the x-intercept of the log function, right? So I have a table that I did in the previous in Gauteng, right, in the function where we were discussing on sketching the log function, and basically I discussed how the shape would look and also the feature. So here what I want is the feature, right, is that we see the fact that, do you see the fact that the log gives us the x-intercept always? This is the case always, and I'm saying this is the case always, and this is when this happens. Maybe I should copy and paste this also. So copy and cut it, right? And this is, I'm gonna paste it here, right? So this is the case always. If our a is equals to 1, our p is equals to 0, and our q is equals to 0, then if you have the log, this is going to be the coordinate always, right? So meaning our d coordinate is going to be what? It's going to be 1 is to 0. So let's go back. This is going to be 1 is to 0. Hope that makes sense, huh? So now we need to determine the value of b. So value of b is at f of x. So we see the fact that f of x, is equals to log bx, right? So before substituting a as the coordinate, right, before substituting point A, is that I'm going to write this in exponential. So first I'm going to write it in terms of y. So it's going to be y is equals to log bx, right? So this is the same as what? This is our base, right? So this is our base. So b is going to be our base. So it's going to be b to the power what? To the power y, which is this one. Then this side is going to be equals to x, right? So we're going to write it like that. Then we're going to substitute our point A. So when we substitute our point A, it's going to be 1 over 4 right? Let's go up. So 1 over 4. So 1 over 4 is to 1. So 1 over 4 is to 1, right? So now maybe you asking the fact that why can't we substitute point the x-intercept, which is d, right? So I'm just going to write it here. What would happen? Maybe let's do it in red. Why we can't? Why we do not substitute d, which is going to be what? Which is 1 is to 0. You'll see what's going to happen, right? Is that if I say x, remember I'm going to take this one, b to the power y, then I'm going to get that this side is going to be 0 is equals to b to the power what? So it's going to be b to the power 1. Therefore, b is going to be equals to 0. And b cannot be 0, cannot be 0. Ever, right? B cannot never be 0. So b can never be 1, cannot be 0, can never be 0 and 1. It's anything greater than 1 or between the fraction, which is between 0 and 1. So b can never be 0 and b can never be 1. So that is the reason why we can never substitute this one. Hope that makes sense. So now let me substitute the correct one, right? So substituting the correct one is going to be, x is going to be 1. So it's going to be 1 over 4. Let me go back to black. So it's going to be 1 over 4 is to b to the power 1, right? So therefore, b is going to be equals to 1 over 4. So that's going to be your b. B is going to be equals to 1 over 4. So now we're going to do 5.3. They say determine the value of m. So let's go back and see where m is. M is here. Do you see the fact that m is here? It's at k at x. So we see the fact that m is k of x is equals to m, right? X plus what? It's mx minus 3, right? Minus 3. So we need a coordinate on the line k of x. So we see the fact that the line d is the line that's on k of x, the one that we find. So we're going to substitute d to find m. So we're going to substitute d, right, which is going to be 1 is to 0 to solve for m. So this is going to be 0 is equals to m, and this is going to be 1 minus 3. So therefore, this is going to be 0 is equals to m minus 3. Take the 3 to the other side. It's going to be positive 3. So it's going to be positive 3. So it's going to be 3 is equals to m. So therefore, our m is equals to 3. So that's how you would solve this question. So now we're going to do 5.4. which is we need to write the domain of f of x. We see the fact that f of x is the log function, which falls under here, right? Which falls under here. This is how our f of x looks, and we're looking for the domain, and this is going to be the domain for our f of x. So just looking at the table, right? So we know that the domain is what? Is x is greater than 0. And if you are dealing with the log function, this is always going to be the domain, which is from this features table. Hope that makes sense, Anna. So now we're going to do 5.5, which is determining the inverse of f. So we know that f of x is equals to, let's go up. We know that f of x is equals to log, but we solve for b, which is b was 1 over 4. Let's go back. Then this is going to be x. So finding log, we need to change f of x into being y. So it's going to be y is equals to log. Then it's going to be a half. Then it's going to be x. Then swap. To find the inverse, we need to swap x and y. So we're going to be x is equals to log a half. Then this is going to be y. So therefore our base is 1 over 4. This is going to be our base. Then we need to make y the subject, right? So we need to make y the subject. We need to make y the subject. So it's going to be y is equals to, then this is going to be to the power x. Then therefore we know that F inverse is basically equals to 1 over 4 to the power x. Or you can also use the table. Do you see? The table shows you if you have this, this becomes this, where b becomes there, then x, then this is y. Hope that makes sense, right? So that's how you find the inverse. So now we're going to do what? We're going to do 5.6, which is determine the values of x for which 1 over 4, right, is between this. So what we have is the following, is the inverse, right, is between 16 and 1 over 4, right? So this is given as your y, right? So this is the same as the y of the inverse. So this is going to be the same as y is between 16, right, and 1 over 4. And I need to solve for x. So to solve for x, we have that y to, I'm going to start with this one first, and let's color coordinate it. We're going to start with this side first, right? So we know the fact that if we have y, right, is equals to 1 over 4, right, which is the same as F inverse is equals to 1 over 4, right? And we're solving for x, but we know the fact that the inverse is the same as what? It's 1 over 4, so it's the same as 1 over 4 to the power x is equals to 1 over 4. Hope that makes sense, right? So now solving for x, so we're going to drop the exponent. So this is going to be x is equals to, this is the same to the power 1. So this is going to be equals to 1. So that is what we're going to have, right? So this is going to be equals to 1. So that is going to represent what? This is going to represent the yellow side, right? So now doing the blue side. So doing the blue side, it's going to be the same as y is equals to 16, which is the same as F inverse is equals to 16, which is the same as 1 over 4, right, to the power x is equals to 16, right? So that's what we have. Then we know the fact that 16 can be written as what? It can be written as to the power 2, right? So 16 can be written as what? 4 to the power 2. So this is going to be the same as 1 over 4 is equals to 4 over 2, right? 4 over 2, 4 to the power 2 gives me 16. So I can write this in terms of 4 to the power something, because this is the same as 4 negative to the power negative 1 is to the power x is equals to what? It's equals to 4 to the power 2, which is, this is the same as 4 to the negative x is equals to 4 to the power 2. Drop the bases. It's going to be negative x is equals to 2. So therefore, x is equals to negative 2. So that is for that side, right? So this is for this side, right? So now we need to rearrange it, right? We know the fact that the smallest one is what? This is going to be the smallest one. So remember the fact that the inequality is like this. So instead of having y, we're going to have x. So x is going to be here, right? And remember the fact that it's equals to, so it's going to be, the inequality is going to be equals to. Here's the smallest number, smallest x, and this is the largest x, largest x. So the smallest x is negative 2, so it's going to be negative 2, and the other side is going to be positive 1. So that is the inequality for this when it's moved to this. Hope that makes sense, Anna. So now we're going to sketch F inverse and K inverse in the same set, in the same axis, and clearly indicate the what you call this, the intercept and axis, right? So now I'm going to use this, our original graph that they gave us, to sketch it, right? So what do we know? We know the fact that inverse is swapping your x and y, meaning your x-intercept becomes your y-intercept and your y-intercept becomes your x-intercept. So now just focusing on this one, right? Focusing on this one, right? Is that it's going to be the same function, but it's that it's going to change, right? So since here is the x-intercept, meaning here is going to be the y-intercept, right? So it's going to be the y-intercept, so meaning the y-intercept, meaning d prime is going to be there. So this is going to be d prime, right? And that's going to be there. And that is going to be at 1, right? Then since it's at 1, do you see the fact that our graph here is the positive positive y-axis, and it goes up at the negative y-axis, meaning it's the same thing but in the x-axis. Since it goes down in the positive y-axis, meaning it needs to go down like this, and it needs to go up on the other side, which is the negative x-axis. So our graph is going to go like this. Our graph is going to go like this. So that's how our graph is going to go, right? So this is what? This is our F inverse. So now let's do K, or what you call this, K of X, right? So let's look at the original first, and we're just going to mark it in black. We know that this point is what? This point is 1 is to 0, right? And this point, after finding K of X, so we know the fact that at K at X, so let's go up, right? We know the fact that it's M negative 3. Negative 3, remember this one gives us the the y-intercept, right? So this gives us the y-intercept, right? So we know the fact that this is going to be negative 3. So this point here is going to be negative 3, right? So now, meaning for the inverse is that this negative 3, do you see that negative 3 here is going to come here? It's going to be here on the x-axis. So this, since it's the x, is the y-intercept, the y-intercept becomes the x-intercept. So negative 3 is going to be here for the K inverse. Then this positive 2 is going to be there. Do you see the fact that it's here? Which represents the, since it was what? It was once the x-intercept becomes the y-intercept, which is already there. So now this is going to be what? We're going to connect two lines now. So it's going to be like this. So let me just do it properly. Connect the 2 points. Just like this. And this is going to be what? This is our K inverse. Right? Because you're just changing your X and Y. So now let me just write it properly. Right? So let me just do it like this. Drawing the Cartesian plane. Right, and we know the fact that this is going to be y and this is going to be x, right? So now I can delete this one and just, yeah, and this is going to be how you would sketch both graphs. Hope that makes sense, Anna. So now we're going to do finance. So we're going to do question 6. So 6.1, it says Johnson deposits an amount of 10,000 into a savings account that pays an interest of 7.15% per compounded quarterly, right? So we know that quarterly means 4, right? So we know that quarterly means 4. So 6.1.1 says calculate the effective rate. So I'm going to write the formula of the effective rate. So we know that the formula for the effective rate is 1 plus 1 effective, right, is equals to 1 plus I, then divided by m, and this is to the power m, right? Where our effective rate is this one, the I is the interest that they give you, m is the quarterly, which in our case means 4. Hope that makes sense, right? So now let's put that inside a block. So let's put that inside a block. So now to calculate, we need our I and m, right? So we know the following. We know that I is equals to what? Is equals to 7.15%. But we need to change it. So it's going to be 7.15, right, divided by 100, which is going to give me 0.0715 or 715, right? Hope that makes sense. And then we need m. We see that m is quarterly, right? Is quarterly. So therefore, m quarterly means 4. So it's going to be 4. So with that said, let's substitute into the formula. So it's going to be 1 plus I effective, right, is equals to what? Is equals to 1 plus then 0.0715 divided by what? Divided by 4 and to the power 4, right? Then we're going to take 1 to the other side. So it's going to be I effective. It's going to be 1 plus 0.0715 0.0715 divided by 4, then to the power 4, then it's going to be minus 1. Punch that into the calculator. We're going to find the fact that our effective rate, so it's going to be our effective rate is basically going to be equals to 0.0, right, 7, and this is going to be so it's 1 2 3, so it's 3 decimals, so it's going to be 0.734, right, which is going to be the same as the effective rate is equals to 7.34%. So that's going to be your effective rate. Hope that makes sense. Now we're going to do 6.1.2, obviously using the information, which is this one, right? It says, how long will it take for the investment to grow to 17,628.78? So using the compound, the compound interest, the compound formula, which is given as A is equal, I'm going to write it in terms of M, right? So it's going to be P divided by 1 plus I divided by M, then to the power N multiplied by M, right? So using this formula, let's write what we given, right? So we know the fact that we're looking for N, right? The amount. We're looking for what? For how long does it take, meaning the amount of years, right? So we know the fact that we have the following. We have A. So A is what we wanted it to grow to, which is 17,000, right? 628.78. Then P, right? P is the starting value. Our starting value is 10,000, right? So we know that P is going to be 10,000. So if we invested 10,000, right? 10,000. Then we need I. I remember the fact that it's going to be this one, right? Because that's the same interest. That's going to be I. So it's going to be what? It's going to be 0.0715. Then we need M. M is the quarterly, which is 4. So we know the fact that it's going to be 4. Then what we're looking for is going to be our N, right? The how long. So now let's substitute. So we know the fact that it's going to be 17,628.78 is equals to 10,000, right? Then it's going to be open bracket, it's going to be 1 plus, then it's going to be what? It's going to be 0.0715 divided by what? Divided by 4. And this is going to be N is what we're looking for. So it's going to be 4 multiplied by N, right? So now we're going to clean it up, solving for our N, right? So we're going to take the 10,000 to the other side. So when we take 10,000 to the other side, you're going to have 17,628.78. And this is going to be divided by it's going to be divided by 10,000. And this side, you're going to be left with what? You're going to be left with 1 plus 0.0715, and this is going to be divided by 4, and this is going to be 4N, right? So that's what we're going to have. Then now, I'm not going to punch anything. I'm not going to simplify anything, right? Is that remember the fact that this is what we want to make the subject, because that's where N is. And since that is that, then we need to change this being the subject, meaning we're going to change the whole thing into being a log. So we're going to have 4N this side, then we're going to have log, right? So what is our base? The base that we had for to the power 4N is going to be the base that's going to be here. So it's going to be what? It's going to be 1 plus 0.0715 divided by 4, right? Then here, the number that's going to come here is going to be this one. So it's going to be what? It's going to be 176, so 628. So it's going to be 628.78 divided by 10,000, right? Hope that makes sense. Then now, when you punch this whole thing into the calculator, right, you're going to get the following. So 4N, right, is going to be equals to what? It's going to be equals to 32. So when you punch this, right, in the calculator, you're going to get 32. Therefore, dividing both sides by 4. So therefore, N is going to be equals to 32 divided by 4. Therefore, our N is going to be equals to 8, right? So it's going to be 8 years. So it's going to take 8 years, right, for our 10,000 to become this amount. So that's how you would solve this question, Anna. So now we're going to do 6.2. It says Mr. Senpai took out a home loan of 1 million at a rate of 11.2.5%, right? per compounded monthly. So let's take out the most important part. So the fact that we know the fact that he took up a loan that cost 1 million, and the interest rate is this one, but it's compounded monthly, meaning it's going to be divided by 12. Our N is going to be divided by 12, and over a period of 20 years. So this is how long the loan is, right? Then they say the fact that the loan is repaid via monthly installment, and they give us the monthly installment, which is this one. Then the first question says determine the outstanding balance after the 125 payment, right? So what I'm going to use here, I'm going to use the present value formula, right, to basically calculate the outstanding balance. Everything's going to be the same, but how we determine N is going to be different. And I'm well aware, if you've watched my master series, that I've used another method. You can use that method or you can use this method, right? I'm using the present value because I feel like it's the quickest, but you can use the other method where you're using the future value and the compound interest. Hope that makes sense, right? So using the present value, so it's going to be the present value. So we know that the present value, which is going to be P, is equals to what? Is equals to X. Then we're going to have 1 minus open bracket is going to be 1 plus I divided by M. Then this is going to be negative N multiplied by M, right? Square bracket. Then this whole thing is going to be divided by I divided by M, right? So now we need the following. We know the fact that we need what? Since we want to know the outstanding balance, we're solving for P, right? So we're solving for P. So we know the fact that the outstanding balance, so the outstanding balance, outstanding balance, it's basically what is equals to P, and that's what we're looking for. Hope that makes sense, right? So we know that the monthly installment is equals to X is equals to the monthly installment, which is 10,429.56, right? Then we know that our interest rate is going to be what? It's going to be 11.25. So it's going to be 11.25%, which is the same as 11.25 divided by 100, which is going to be equals to 0.1125, right? So that's going to be our what? That's going to be our interest. Then we know the fact that our N, right? Our N is equals to what? It's going to be equals to our N, right? Our N multiplied by N, right? So this, the N multiplied by M, that's what everything changes, right? So that's where it changes. So first, we know the fact that our M is equals to 12, so that's sorted. But then our N multiplied by M, right? That's where it changes. Since we're looking very specific, since we're looking for the outstanding balance, right? We need to know how many, how many monthly installments are there. So to find the total monthly installment, so this one for the outstanding balance, right, is going to be the total, right? So the total monthly installment minus the one paid, right? The paid one, the paid monthly installment. So the remaining, that's what's going to be your N multiply, your N multiplied by N. So minus your monthly installment, the paid monthly installment. Hope that makes sense, right? To find the total is going to be the number of years, which is going to be 20 multiplied by 12, right? Minus, they said the fact that we want to calculate after what? After 125 payments. So that's the one that's paid. So it's going to be 125, right? So now when you punch that into the calculator, right? When you punch that into the calculator, you're going to find the fact that that is going to be equals to 115. So that is going to be basically your remaining installments that you're going to be paying, right? So N multiplied by N is also the remaining. So let me just put it here. It's going to be the remaining. The remaining payments, which makes sense, right? Remaining payments, right? So that's what you're going to have. So now we have everything we can substitute, right? So let me put this into this. Then I'm gonna just cut it again because I want it, duplicate it, cut it. Then I'm going to substitute, right? So I'm going to paste it here. Delete this. Then we know the fact that we're looking for P, so let's substitute. So P is going to be equals to what? P is going to be equals to 10,000. So it's going to be 10,492, comma 56, right? Then open bracket, we're going to have 1 minus, then it's going to be 1 plus, then our interest, remember the fact that is what? It's 0. It's 0, comma 0. So it's 0, comma not 0. It's 0, comma 1, 1. So it's going to be 1, 1. 1125, right? And that's going to be divided by 12. And this is to the power of n multiplied by m is basically going to be minus what? Minus 115. So it's going to be 115, right? Then square bracket, and this whole thing, right, is going to be divided by what? Divided by 0.1125 divided by 12. So you're going to find that your outstanding, which is P, is equals to 73. So it's going to be 736, right? Then it's going to be 498, comma 33, right? So that's how you will find your outstanding. Hope that makes sense, Anna. So now we're going to do 6.2.2. It says Mr. Senpai had financial difficulties and was unable to make the following payments. So he was unable to make the 126, the 127, the 129, the 128, 29, and also the 130 payments. So he missed how many payments? Let's calculate. 1, 2, 3, 4, 5. He missed a total of 5 payments, right? Then they say the fact that the bank agreed to restructure the loan so that he pays off the loan, right? He pays off in the same amount of time. Then they say determine the new monthly installment. So what we need to do is that since this was the outstanding balance, right? To find the new installment, we need to basically see how much this monthly installment is going to be after missing 5 payments, right? And to do that, we need to determine the new loan amount for the remaining period, which to do that is that we're going to use the outstanding, then we're going to grow it within the 5 months, because of even if you don't pay, if you stay and you don't pay your loan, right, the money keeps on growing with the interest that they give you. Hope that makes sense, right? So we need to calculate the new loan amount, right, after the 25 terms, and also check how much it has grown, right, in interest for the past 5 months, right? Then we're gonna take that loan, the new loan amount, right, and basically see how much remaining time it was, like the number of his installments, right, how much they're remaining and how much he needs to pay. Hope I'm making sense, right? So now let's do that, right? So we need to have the new loan amount after the 25 terms. So we know the fact that the new loan amount, so we know the fact that the outstanding balance, right, the outstanding balance after the 125 payment is equals to, we calculated it here. So you know the fact that this is going to be the amount, right? So we know the fact that that is that, right? But now we need to calculate the new outstanding balance after missing 5 payments, right? So new outstanding balance, so new outstanding balance, so outstanding balance, right, after missing 5 payments. So we know the fact that that is going to be what? We're going to use A, right? So A, to calculate that, how much it has grown in interest, because it's going to be A is equals to P. Then it's going to be 1 plus I divided by what? Divided by M, right? And this is to the power what? To the power N multiplied by M, right? Then now let's check how we need to do this. So we need to know the new. So we're looking for A. That's what we're looking for. Then P is your previous outstanding balance. So P is going to be your previous outstanding balance, which is going to be 736,498,33, right? Then I is going to be the same interest, so which is going to be in our case 0.11. So it's going to be 0.1125, right? Then N, right? M, right, is going to be equals to what? To 12 months. Then our N multiplied by M, right, is going to be the missing payment, which is going to be 5. So it's going to be equals to the missing payments. Let me just do this. Missing payments, right, which is in our case the missed payment. So missed payment, which is equals to what? Which is going to be equals to 5 months, right? So now we have everything. So now let's calculate the new amount. So we know the fact that this is going to be equals to what? So A is going to be equals to 736, then 498,33, then open bracket is going to be 1, then this is going to be 0.1125 divided by 12, and your missed payment is going to be 5. Then A is going to be equals to, so when you punch that into your calculator, we're going to find that our A, right, after the missed payment, right, after missing 5 payments, is going to be 7, right, 1, and this is going to be 675,17, right? So that is the new outstanding balance after missing 5 payments, right? But now we need to find the new monthly installment. So using the PV, so finding, so let me just say finding the new installment. So the new monthly installment. So to do that is that we're going to use the p-value because of is the loan, right? The present value formula. So we know the fact that that's going to be x, and this is going to be 1 minus open bracket 1 plus I, not just I. Remember the fact that I like writing it in terms of m. So it's going to be like this. Then it's going to be minus what? Minus n multiplied by m, right? Then this whole thing, right, it's going to be equal, it's going to be divided by I divided by m, right? Remember the fact that we're looking for the new monthly installment, so we're looking for x, right? So we know that P is basically going to be equals to what? It's going to be equals to the new balance, right? So it's going to be 771, then it's going to be 65, it's going to be 675, so 675, 10, right? Then we know the fact that x is what we're looking for, right? Then I is going to be still the same, which is going to be 0.1125, right? So I is not going to change. Then m is not going to change too, right? M is not going to change, which is still going to be what? It's still going to be m is going to be still 12, right? Then our n multiplied by m, right, is going to be what? Remember the fact that we've paid up. So we know that the total, right? So we know the fact that it's going to be the total installment. So it's going to be total installment, which will make sense. It's going to be the total installment minus what? So it's going to be the total installment minus the ones that paid. So the ones that we paid. So it's going to be minus the paid installment, right? Then also we're going to subtract the minus the missed installment. So minus again the missed installment. Then with that said, now let's fill it in, right? We know that the total is what? It's 20 years, remember, multiplied by 12. right? Then the paid, we paid 125 from the previous when we were looking for the outstanding, looking for the outstanding. We paid 125. But remember that we missed 5, right? So when you punch that into the calculator, so that is going to give you 110. Hope that makes sense. So now we know the fact that this is going to be 110. So now we can fill in, right? So we know the fact that here, so we can fill it in. So let me just move and do it here. So let me just copy and paste this. Duplicate. Cut. Let's go down, right? So now let's fill in the information that we have, right? So we know the fact that P, right? So we know that P is going to be this value. So we're going to say 77. So it's going to be 77. So it's going to be 771. Then this is going to be 675, comma 10 is equals to X is what we're looking for. Then we're going to say 1 minus, that's going to be 1 plus, right? Then this is going to be 0, 1125 divided by what? Divided by 12. And this is going to be negative 110. Then close. Then we're going to have this whole thing is going to be divided by what? Divided by 0, 1125 divided by 12, right? So we want to make X the subject. Don't simplify anything. So take this to the other side. So we're going to have 771675, 10. Then since it's dividing, it's going to be multiplying by 0, 1125 divided by 12 is equals to X, right? And this is going to be 1 minus, then it's going to be 1 plus 0, 1125 divided by 12, and this is minus 110, right? Close square bracket. Then I'm going to take this and I'm going to divide it here. So this is going to give me 1,675,10 multiplied by 0, 1125 divided by 2, right? And this whole thing is going to be divided by what? It's going to be the square bracket. So it's going to be 1 minus, then it's going to be 1 plus 0, 1125 divided by 12 to the power negative 110. Square bracket is going to be equals to X. So therefore, when you punch this whole thing into your calculator, your X is going to be equals to what? Your X is going to be equals to 11. Then it's going to be 27, right? 3,50. So that's going to be your new monthly installment. Hope that makes sense, right? So now what we're going to do, we're going to do calculus. So we're going to do 7.1. It says determine f prime from the first principle if f of x is equals to negative 5x squared, right? So the first thing is that what is f prime using the first principle? So we know the fact that f prime of x is equals to the limit when h approaches 0, right, of h of f x plus h, then minus f of x. That whole thing is divided by what? Is divided by h, right? So let's put this in a block. So that's what we're trying to solve using the first principle. So what we're going to do is that we're going to find f of x plus h, then the whole numerator, simplify it outside, then put it back, right? So that's what we're going to do. So we're looking for f of x plus h. So now wherever I see x, right, I'm going to put x plus h. So it's going to be what? It's going to be negative 5. Then it's going to be x plus h all squared, right? So now we're going to simplify it. So simplifying it, it's going to be negative 5, open bracket. This is going to be x squared. So let me just zoom it in. So you're going to have x squared plus 2xh plus h squared, right? Distribute the negative 5. So that's negative 5x squared, right? Minus 10xh. Then lastly, it's going to be minus what? Minus 5h squared, right? So that's what we're going to have. Then now we're going to do the entire numerator, which is going to be what? Which is f of x plus h minus f of x. So that's going to be equals to what? It's negative 5x squared minus 10xh minus 5h squared minus, what is f of x? F of x is minus 5x squared, right? So now, to know that you're doing the right thing, f of x completely needs to cancel out with one of the terms here. If it cancel out, you're doing the right thing. So now let's do this. So it's going to be 5x squared minus 10xh minus 5h squared. Then this is going to be plus 5x squared. So this and this are going to cancel out because it's the same thing, different sign. So they're going to cancel out. So you're going to be left with negative 10xh minus 5h squared, right? So our goal here, right, to simplify this is that we need to get rid of this h. So what I like doing is taking out that h out. So it's going to be h, then this is going to be negative 10x, then it's going to be minus 5h, right? So now we're going to take that and simplify it back here. So just to cut down time, we're going to take this, I'm going to duplicate it, cut it, and I'm going to put it down. So we're looking for this. So take out this, yes. So now substituting. So we're going to have the limit when h approaches 0 of h, then it's going to be negative 10x minus 5h. And this is going to be divided by what? Divided by h. Then the h's are going to cancel out. You're going to be left with the limit when h approaches 0, then it's going to be negative 10h minus 5h, right? So now we're going to substitute here by 0, h by 0, right? And when we substitute, the limit drops. So it's going to be what? It's going to be negative 10x. So go back. It's going to be negative 10x minus 5. Then this is going to be 0, right? And this is going to be negative 10x. So that's your final answer for this question. So now what we're going to do is that we're going to do 7.2. So it says determine dy over dx if y is equals to y cubed minus 27 divided by x minus 3, right? So now we see the fact that this, the numerator here, is a what? It's a difference of 3 cubes, right? It's a difference of cubed. So we know the fact that since it's the difference of cube, we can basically what? We can expand this, right? So we can expand it using this identity. So we know the fact that first thing first is that we're going to expand this so we can get rid of this denominator, right? So that we can apply this rule. Hope that makes sense, right? So now, first thing first is that let's write the identity. The identity says it's a cubed, right, minus b cubed is equals to what? Is equals to a minus b. Then it's going to be a squared. Then this is going to be plus a b. Then last is going to be b squared, right? So this is going to be inside a block. So that is an identity that we're going to apply in the numerator. So first we're going to simplify y. So we see that y is equals to x cubed, right, minus 27. Then that's going to be divided by x minus 3. So from here, we need to find a and cubed. So to find a, we see the fact that a cubed, so we see that a cubed is equals to what? It's equals to 20. It's equals to x cubed, sorry. So square root both sides. We see cube root both sides. So cube rooting both sides. We see the fact that is a is equals to x, right? So with b, we see that b cubed is equals to what? Is equals to 27. So we see the fact that it's equals to 27. Cube root both sides. We see that b is basically equals to 3, right? So now let's substitute, right? Putting in the identity. So substituting using the identity is that y is equals to, then a is what? Is x, so it's going to be x minus 3. Then it's going to be what? It's going to be a squared, so it's going to be x squared, right? Then it's going to be plus a, so it's going to be 3x, so it's going to be 3x then it's going to be plus 3 squared. So this whole thing is going to be divided by what? By x minus 3, right? So therefore y is equals to x squared. So it's going to be x minus 3, then it's going to be x squared plus 3x, then it's going to be plus 9, right? And this whole thing is going to be divided by what? This whole thing is going to be divided by x minus 3. We see x minus 3 is going to cancel out. So they're going to cancel out. So you're going to be left with y is equals to x squared plus 3x plus 9. And this is the perfect form because of now we can apply this rule, which is y, if y is equals to ax to the power n, then the first derivative using this rule is going to be y prime is equals to a multiplied by n, then it's going to be x is going to be n minus 1. And the other rule that you need to remember is when y is equals to a, which is the same as y prime is equals to 0. So these are the only two rules that you just need to know. All right, hope that makes sense. So now applying that rule, so here we know the fact that dy, remember the fact that in this question they say dy over dx. So now applying the rule, you're going to say dy over dx is equals to, let's apply the rule. So we see the fact that here it's 1 and the power is 2. So this is the same as 1 multiplied by 2. Then it's going to be x2 minus 1, right? And this is going to be plus 3. This is the same as to the power what? To the power 1. So it's going to be 3 multiplied by 1. Then it's going to be x1 minus 1. And the constant, which is 0. So it's going to be plus 0. So let's clean this up. This is the same as 2x plus what? Plus 3, right? Then x to the power 0 is 1. So x to the power 0 is going to be 1. So our final answer is going to be 2x, right? Plus 3. And that's how you would solve this question. So now what we're going to do, we're going to do 7.2.2. So the first thing first is that when you're dealing with this one, right, to get rid of this dx is that you need to basically apply this rules, right? These rules. But we see the fact that for us to apply these rules is that our terms needs to be in single terms like this, right? It needs to be like this, meaning it needs to look like something like this, right? So we do not like working with what? We do not like working with brackets. We don't like that, right? So we need to clean up the square bracket. So let's clean up the square bracket first. So cleaning up the square bracket, we see the fact that x, then open bracket, is going to be 4 minus x to the power 1 over 2, right? Distribute the what? Distribute the x. So this is the same as what? As 4x, and this is going to be minus x multiplied by x to the power 1 over 2, right? So now this is the same as having what? 4x. Then since the powers are, since the base are the same, this is minus x, then this is going to be 1 plus 1 over 2. So therefore this is going to be 4x is minus what? Minus x. It's going to be what? This is going to be equals to 3 over 2. So from here, we're using this law, which is going to be a multiplied by a to the power x multiplied by b to the power y, a to the power x and a to the power y. Since the base are the same, we know the fact that we add the powers. So this is the rule that we use there. Hope that makes sense. So it's using exponential rules, right? So now we see the fact that we do not see any power, any what you call this, we do not see any brackets and any what? Any square root. So we can basically apply this rule. So let me just put it back in. So this is the same as looking at dx, and here is going to be 4x minus x 3 over 2. So now when we apply the rule, right? So when we apply the rule is that we drop the dx. So meaning here is going to be 4 multiplied by 1, right? So it's going to be 4 multiplied by 1. Then it's going to be x 1 minus 1 minus, what you call this, minus here is the same as having 1. So it's going to be 1 multiplied by 3 over 2. Then it's going to be x, and it's going to be 3 over 2 minus 1. So let's clean this up. This is the same as 4 to the power x to the power 0, right? And here's going to be minus 3 over 2. Then it's going to be x, and it's going to be 1 over 2, right? So now cleaning it up is the same as having 4 minus 3 over 2 x to the power a half. And that's your final answer for this question. So now we're going to do 7.3, but I'm not going to do 7.3 necessarily because of it's the same question as the Gauteng paper, right? The question for that is basically, let me just show you. 8.3 is the same thing as, let's zoom it in, it's the same thing as 7.3, right? So the difference here, so let me just do this. The difference is that here, right, is f of x and this side is h of x. But h of x is exactly the same thing. Do you see that? Right? And another thing is that here they said h, what you call this is 8 and 4. The numbers are changing. That's it, right? So what I'm going to do is that if you are part of the membership, you're going to have the PDF, so the actual solution, right, to how to solve this one. So you can try it, right? And this is going to be the final answer. Your final answer is this, right? But don't worry, is that I'm going to link under this, I'm basically going to link this section of answering this. It's exactly the same thing. How you solve this one, right? It's exactly how you're going to solve this one. The difference is that the numbers, and the other one is h of x and the other one is what you call this one is f of x. Hope that makes sense, Anne? So now what we're going to do, we're going to do question 8, right? So question 8, it says given that f of x is equals to 2x cubed plus x squared minus 13 plus 6, right? The first one, it says if one of the x-intercept is equals to of f is equals to 2, meaning x is equals to 2, then determine the other two what you call this x-intercept. So I'm going to use this diagram. So let me just paste this diagram. I'm going to use this diagram, right? So in the diagram is that this factor, right, comes here. So this 2 comes here, one of the x-intercept, which is going to be 2, comes here. Then here it's going to be the coefficient of x cubed. So here it's going to be a, b, c, and d. So that's what we're going to put here, right? So let's do that. So we know that a is 2, b is positive 1, c is negative 13, and d is 6. So this is the numbers. This is a, here is 1, which is, it's not there. It's b, then this is c, and this is d. Hope that makes sense, right? So the first step, and this part, maybe let me just do this. 4. Let me cut it, right? So the first part is that we need to drop the first term, right? So drop it like this, and it's gonna come here, right? Then after dropping the first term, I'm gonna do all the calculations here. You take that term, multiply by the factor that you have. So when you say 2 multiplied by 2, it's going to give you what? It's going to give you 4. And that number comes here, right? Then you add. So here you're going to be adding, right? Then when you add, you're going to get 5 here. So you're going to say, take that 5. So you're going to say 5 multiplied by that factor, which is 2. And that's going to give me 10. So 10 is going to come here. Then when you add, you're going to get negative 3. So when you say negative 3 multiplied by 2, it's going to give me what? It's going to give me negative 6. So if you have 6 here, when you add negative 6, when you add, you're going to get 0. To know that you're doing the right thing is that here you always need to get 0. So this is the coefficient of what? Of, this is going to be a. So this is going to be our a, our b, our c. From where? From this. From y is equals to what? To ax squared plus bx plus c. And the nice thing is that this form we can factorize, right? So now our y, right? So our y in terms of the x-intercept is that our y, so let me just do this, right? So our y, which is f of x, can be now written as, so f of x can be written as what? Can be written as this factor. Remember the fact that this is x is equals to 2. So when you take it to the other side, when it's inside a bracket, it's going to be negative, right? So this factor is always the negative sign when you put it here. So it's going to be x minus 2, right? And here it's going to be what? It's going to be 2x squared plus what? Plus 5x, right? And this is going to be minus 3. Hope that makes sense, right? But remember the fact that we're looking for what? We're looking for the x-intercept. So we're looking for the x-intercept. So meaning we need to let y equals to 0. So y is the same as f of x. So that's the same as 0 is equals to x minus 2 then it's going to be 2x squared plus 5x minus 3, right? So now we already have this, so we can factorize this, right? So now factorizing this, right, you can use the your quadratic formula to factorize that. So we know the fact that 0 is going to be equals, the first bracket is going to be x minus 2, then here is going to be 2x, right, minus 1, then the other one is going to be x plus 3, right? So equate each bracket by 0. So let me just go up. So when we're equating each bracket by 0, it's going to be x minus 2 is equals to 0, or it's going to be 2x, right, minus 1 is equals to 0, or is going to be x plus 3 is equals to 0. So let's sort this out. So we're going to have x is equals to 2. Then you're going to have 2x is equals to what? Is equals to positive 1. So therefore, x is equals to 1 over 2. Then lastly, you're going to have x is equals to negative 3, right? So now that is your x-intercept. So this 3 is going to be your x-intercept. Maybe let's put them in coordinates. So this is going to be 2 is to 0. This one is going to be a half is to 0. And lastly, you're going to have negative 3 is to 0. So that's your x-intercept. Hope that makes sense. So now we're going to do 8.2. So it says determine the coordinates of the turning point, right? So we know the fact that to find the turning point, you need to find the first derivative and equate it to 0. This finds the x coordinate. Then after finding the x coordinate, we're going to find the y by substituting the values that we get, right? So we know the fact that this is how you find the turning point, right? So now with that is that we know the fact that we have f of x is equals to what? So we know that our f of x is equals to, let's go up. Okay, let me just, f of x is 2x cubed. So it's going to be 2x cubed. 2x cubed plus x squared plus x squared. Then it's going to be minus 13. So minus 13x. And lastly, it's going to be plus 6. So we need to find the first derivative. So it's going to be 2 multiplied by 3. X is going to be 3 minus 1 plus 1 multiplied by 2, right? It's going to be x. It's going to be 2 minus 1. That's minus 13 multiplied by 1. It's going to be x. It's going to be 1 minus 1. Then 6 is going to be 0. So f prime, when you simplify it, right, you're going to get is equals to 6x squared, right, plus 2x. Then lastly, it's going to be minus 13. So we need to equate this by 0. So it's going to be 0 is equals to 6x squared plus 2x minus 13, right? So now we need to solve for x here, right? So here we're going to use the quadratic formula. So we know that the quadratic formula is x is equals to what? Is equals to negative b plus or minus square root of b squared minus 4ac, right? And this whole thing is divided by what? Is divided by 2a. So we know the fact that our a is what? We know that a is equals to 6, b is equals to 2, and c is equals to negative 13. So now let's substitute. So we know that x is equals to negative, then this is going to be 2 plus or minus square root, and this is going to be what? 2 all squared minus 4, and this is going to be 6, then this is going to be negative 13, right? And this is going to be, this whole thing is going to be divided by what? It's going to be divided by 2, then it's going to be 6, right? So now let's clean this up. So this is the same as having x is equals to negative what? Negative 2. Then this is going to be plus or minus. Then this is going to be the square root. This is going to be 4 minus what? Minus. So it's going to be 4 plus, sorry, it's going to be 4 plus 312. And this whole thing is going to be divided by what? It's going to be divided by 12. So clean it up further inside the square root. So it's going to be minus 2 plus or minus. Then it's going to be the square root of 316 divided by what? Divided by 12, right? So now this is the same as having x is equals to negative 2 minus square root of 316 divided by 2, or x is equals to negative 2 plus square root of 316 divided by what? Divided by 2. Right? So now when you punch this into the calculator, you're going to get x is equals to what? Our x is going to be equals to negative 1,65. Then here it's going to be x is going to be equals to 1,31. Hope that makes sense, right? But we're not done. Remember the fact that we're looking for the y coordinate. So for this one, we're looking for f4. So finding the y coordinate of TP, right? So we're going to be looking for f of negative 1,65, right? Which is going to be what? Which is going to be 2 open bracket negative 1,65 all cubed. So meaning we're substituting back to f of x, not f prime but f of x. Hope that makes sense, right? So this is going to be plus negative 1,65 all squared. Then it's going to be minus 13, so it's going to be negative 1,65, right? Then this is going to be plus 6. When you punch that into the calculator, you're going to get this as 21,19, right? Then now we're looking for f of 1,31, so it's going to be 2, that's going to be 1,31 all cubed, plus this is going to be 1,31 all squared minus 13, it's going to be 1,31, right? Then it's going to be plus 6, and this is going to be equals to what? And when you punch that into the calculator, it's going to be minus 4,82, right? So now the coordinate of the turning point is going to be negative 1,65, right? And 21,19. And the other one is going to be 1,31 is to negative 4,82, right? So that's how you find the coordinate of the turning. So now we're going to do 8.3. So it says draw a sketch of f. So we need to draw f, right? So with drawing the sketch, right, we need the following. So sketching a cubic function. So sketching a cubic function, we need the following, right? We need the shape. So A, which is the shape, right? So we need A, which is the shape. So we see the fact that in our case, A is equals to, let's go up. We see that our A is equals to 6, which is positive. So we know the fact that 6 is positive, meaning our graph is going to look like this. It's going to go up, down, and up. So this is the shape, right? 2, we need the x-intercept. So we know that our x-intercept is going to be what? Remember the fact that we found them. This is them. So let me just copy and paste them. So we know the fact that this is our x-intercept. So paste. Okay, so let's just do this. Let me just sort out this. Okay, so that's our x-intercept. Then we need our y-intercept, right? So we need the y-intercept. So the y-intercept. So the y-intercept, we're going to get it from here. So where is it? Okay, so from f of x. So duplicate, cut. So go up. Right? So we know the fact that f of x is equals to this. So let me just clean this up. Right? So this D, do you see this D is the y-intercept. So our y-intercept is going to be 0 is to that value, which is going to be 6, right? So lastly, we need so number 4, we need the turning point. So if we need the turning points, we know the fact that the turning points, we found them. Here they are. So duplicate, cut. So this is the turning point, right? So now we can sketch the graph, right? So we're sketching the graph. Let's look at it. Let's see what's the highest value that we need in terms of y. The highest one is this one, right? And the lowest one on the negative side is, I think it's this one, right? Then the highest on x, so we see that the highest on x is this. Okay, so now let's sketch it. So the Cartesian, so we're gonna have a Cartesian plane, right? Where on the positive side it needs to be more, so it's gonna be like that, right? Then now we are gonna take a ruler. I'm gonna fill in my x, so this is gonna be 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be 1, 2, 3, 4, 5, right? So let's hide this. Okay, so we know the fact that this is going to be 1, 2, 3, 4, 5, 6, 7, 8, and this is going to be 1, 2, 4, 5, 6, 7, 8, and this is going to be -1, -2, then -3, and -4, right? So now let's put in the points. So let's start with the x-intercept. So we know the fact that it's going to be 2, +2, so it's here. So I think here, I think there should be another point here, somewhere here. So it's going to be -3 and -4. And this is 5, -5, yes. So we know the fact that it's 2, it's a half. So it's 2, it's a half. So it's going to be, a half is going to be here. It's going to be here. Then lastly, it's going to be -3. So -3 is here. So that's where the graph needs to cut, right? Then we see the fact that we need our turning point. So the first one is -6. So I'm going to just use dotted lines just to show you. So it's going to be -1,6. So -1,6 is between a half. So it's somewhere here. So it's basically somewhere here. That's like negative 6.5, and 21, since we're sketching, it doesn't need to be accurate. So 21, let's say the fact that it's here. So let's say the fact that that's 21,19, right? Then, so meaning this point is going to be there. Then the other point is going to be what? It's going to be 1,3931. So it's before a half. So it's going to be somewhere like this. Yes. So it's going to be something like this. Yes, right? Before a half. Then it's going to be -4. So -4, we can say the fact that it's somewhere here. Okay. So our 2 points, so let me just go here. So our 2 points is going to be what? It's going to be here, the turning point, and the other one is going to be here. Right, and then the y-intercept, right, is going to be what? It's going to be +6. So let's just sketch it. Wherever it lands, it's going to be the y-intercept. Remember the shape that we go up, so it's going to be, so let me go back to black. It's going to be something like this. Okay, cool. Let me just do like this. Yes, going up. Then remember the fact that it curves here. Then it's going to be down. Then it needs to cut at half. So meaning it needs to cut somewhere here. Like this. Then like this. Then like this. So that's the graph, right? So meaning here, it's going to be our 6. So that's going to be our 6. And here, it's going to be -1,65. Is 221,9, and here it's going to be 1,31 is to -4,8. 0.82, right? Then yes. So that's how your graph is going to look. Hope that makes sense on it. So now we're going to do 8.4. It says determine the value of x for which f prime of x multiplied by f double prime is less than or equals to 0. So first thing first is that we need to understand what does it mean, right? What we're looking for, which is f prime of x multiplied by f double prime of x is less than 0. So we're looking for when you're multiplying the two, right, it needs to give you a negative. So when can that happen? It can happen if this one is positive and this one is negative, because we know that a positive multiplied by a negative gives you what? Gives you a negative, right? Hope that makes sense. Or it can happen if this one is a negative multiply, if this one is a positive, when you multiply them together, it's going to give you a negative. But now is that we need to understand when is f prime of x negative and when is f double of prime of what you call as f double prime negative or positive, right? So first, and when, so yes, so when is f double prime f prime negative or positive. So f prime, right, is negative. F prime of x is negative, which is negative is less than 0, right? When the graph, when f of x is increasing. Because this and this means the same thing. So sorry, f of x is decreasing. Made a mistake, decreasing. Right? And f prime of x is greater than 0, which is positive when f of x is increasing, So this, the negative, I'm going to represent it and I'm going to color coordinate it so that everything makes sense. Negative, I'm going to represent it as what? Let me just do this. I'm going to represent it as being red. Then positive, I'm going to represent it as being green. And that's going to make sense when we're doing f double prime and going back to the function, right? So now we're going to highlight increasing and decreasing. So with f of x increasing and decreasing, we need what? We need the turning point, right? So the x value, right, is going to be the turning point. So it's going to be the x coordinate. So it's going to be the x coordinate of TP. And I hate the fact that it's here. There isn't enough space. Let's cut it and put it just here. Yeah, because I need some order. And maybe underline this. Yes, all right. So we need the x coordinate of the turning point. So let's go up. We know the fact that the x coordinate of the turning point when we were solving, go up, it's this one. So let me copy, cut it. So we're gonna put it here. So even before, so let me just put this closer, right? So even before we do the what you call this for f double prime when it's positive and negative, right? Let's now put in here, right? Let's put in the diagram. So to find increasing and decreasing, right? So let's say the fact that we're finding increasing and decreasing is that we're gonna put dotted lines by our x coordinate, right? So it's gonna be from here, then it's gonna be from here, right? Then we're looking for when it's increasing and decreasing. So what you're going to do is that you're going to take your what you call this, you're going to take your pencil, right? Then from left going to right, you're going to trace the graph, right? So we see the fact that it's going up. So we're going to just follow the graph, drawing arrows, right? So let me just do this, drawing arrows. Still dotted. Okay, solid. So drawing arrows like this, because we're finding out increasing and decreasing, drawing arrows like this. following the graph, you're going to follow the graph going from your left to right. So like this, then like this, right? So wherever the arrows are going up, that's increasing, meaning it's going to be the green one. So we're going to just highlight with green. So green is when the graph is increasing. Wherever it's decreasing, it's going to be arrows going down. So I'm going to draw it with this one, right? Then lastly, it's going to be increasing here. So we sorted that out, right? So we sorted that out. So that's sorted, right? So now let's look for when f double prime, right, is negative or positive. So now when for f of x double prime, it's going to be what? F double prime, right, is going to be greater than 0, meaning it's going to be positive, right, when it's concave up. So it's going to be like this, right? Then f double prime is going to be less than 0, meaning negative, when it's concave down, right? When it's going to be like this. Hope that makes sense, right? So now let's put highlighters on it. So this is going to be positive and this is going to be for our negative. Hope that makes sense, right? So now the x value. So now we want the x value. So the x value is always going to be the point of inflation. Point of inflation, but we strictly want what? The x coordinate. Only the x coordinate. Hope that makes sense. So how do we find the point of inflation? Is that it's f double prime of x is equals to 0, right? So we already know what? We already know the first derivative, right? So we already know that f of x. So we already know that f of x is equal. So let me just go take it up, right? So let's go take f of x. I like solving it again. So we know that f of x is this. So we already know that f of x is equals to this. This was given. But we already solved the first derivative, right? When we were finding the turning point, we already know that the first derivative is this one. Now, taking the first derivative to find the second derivative. So let's do that. So it's going to be f double prime of x. It's going to be 6 multiplied by 2. It's going to be x2 minus 1 plus 2 multiplied by 1. It's going to be x1 minus 1. Then it's going to be minus 0. So f double prime of x is going to be basically 6x, right? And this is going to be plus 2, right? Then we're going to have what? So it's going to be 6x plus 2. Yes, no, it's not 6x, sorry, it's going to be 12x. You can see it's going to be 12x, right, plus 2. So we know the fact that this is going to be 0 is equals to 12x plus 2. Take the 2 to the other side. It's going to be minus 2 is equals to 12x. So therefore negative 2 divided by 12 is equals to x. So therefore x is equals to minus 1 over 6. So after finding the point of inflation, the point of inflation is that we need to indicate it on the graph. So we see the fact that it's going to be somewhere here, right? And I've already put down dotted lines, right? And that's where it is, right? So that's our x value, right? So before we do anything is that I'm gonna basically make the highlighter big for this section for increasing and decreasing, because I want to basically indicate the concave up and concave down, right? So I want to be able to see it. So this is going to be for increasing. Hope that makes sense, right? So now we know the fact that concave down or concave up, right, which is going to be this section here, needs to be in green, right? So what I'm going to do is that I'm going to take my pen and I'm going to do green, but I'm going to just make it a big green so that we can see it when evaluating the solution. So this represents my concave up, right? Then the concave down is going to be this one, which is going to be this one, which is like this, which makes sense, right? Which makes sense. Then now the next step that we're going to do, so let me go back to black and go like this, is that the next step is that I'm going to put negative infinity here and I'm going to put positive infinity here. Then I'm going to separate them. Remember the fact that here I talked about the x values, and also here this is the x values, and you see the fact that I put it dotted lines by the x value is to divide our graph. So we know the fact that from a negative infinity till negative 1,65 is going to be the first quadrant. Then here's going to be the second quadrant from negative 1,65 till negative 1/6, right? Then it's going to be, here's going to be the third quadrant. And lastly, this is going to be the fourth quadrant. Then now what we're looking for, remember that we're looking for the following. We're looking for a negative and a positive, right? And we're looking for, so let me just do this. We're looking for a negative and positive. So in our case, we're looking for when the highlighter and the line is a different color. So if the highlighter and the color is a different color, that's part of our solution. So we're going to start here. Do you see from here till going here, the highlighter is green, right? And the pen or the line is red. So this is part of our solution, because that's going to be a negative multiplied by a positive is going to give you what? It's going to give you a negative. Then this section here, do you see the section here? We see the fact that the highlighter and also the line is the same color. So that's not part of our solution, right? And now we're going to go to this section here, which is section 3, which is this section here. We see the fact that the highlighter is red and the line is green. So this section here, let me just emphasize it, right? The highlighter is red and the line is green. So that's part of our solution. And lastly, it's going to be section 4, which is going to be this one, right? Do you see that the highlighter and the pen is the same color? So this is not part of our solution. So our answer here is going to be what? The first section, which is going to be x is an element from negative infinity till negative 1,65, right? Or it's going to be what? It's going to be section 3, which is going to be negative 1/6, because that's the green line, right? Till where? Till 1,31. Hope that makes sense, right? So that's how you would write your solution. So now it says question 9, a drinking glass is in the shape of a cylinder, right? Must hold 300 centimeters cubed, right, of liquid, meaning this is the volume. So they gave us that the volume is equals to 300 centimeters cubed, right? Then they say of liquid, the height of the glass is 8 centimeters and the radius is what? Is r centimeter. Then 9.1, it says show that the height of the glass h can be expressed like this, right? So we know the fact that what are we given? We given the volume. So we know that volume, and looking at what they want is that, so let me just go back. We know the fact that there's 300, meaning this volume is going to play a role, right? So we know that volume, the formula of volume is equals to pi r, right? Pi r squared h. But we know the fact that volume is equals to what? Is equals to 300 is equals to pi r squared h. So making h the subject, this is the same as 300 divided by pi r squared is equals to h. So we just express h in that form. Hope that makes sense. So now they say hence, meaning we're going to use whatever that we used previously. Our previous answer is going to be what we're going to use, right? Hence, determine the value of r, right, for which the total surface area, so meaning the total surface area of the glass will be minimum. So what are we looking for? We're looking for the total surface area being the minimum. So the total surface area, let's call it as A, right, is the first derivative of it is equals to 0. So this means what? This means means the total surface area is minimum, but we're solving for r, so it's minimum. So since we're solving for r, this is the same as, let me just correct it, is SA, which is going to be the surface area when r is inside and is equals to 0. So this is solving for r when the total surface area is equals to 0. Hope that makes sense, right? So that's what we're solving. So we need to find the surface area formula. So we know that the surface area formula, so the surface area formula is equals to what? So the surface area formula in our case, we know the fact that of a cylinder, the surface area of a cylinder is equals to pi r squared plus 2 pi r h, right? So we know that, right? But we also know the fact that h is what? Is equals to 300 divided by pi r squared, right? So the hence, using the hence, because they said hence, we know that h is equals to what? To 300 pi r divided by pi r squared. So now let's substitute, right? So it's going to be SA is equals to pi r squared plus 2 pi r, then this is going to be 300 divided by pi r squared, right? So we know that, right? So we see the fact that now everything is in terms of what? Is in terms of r, right? So this is the same as SA of r is equals to, let's clean this up, it's going to be pi r squared plus, then 2 multiplied by 300 is going to be 600, right? It's going to be pi r divided by pi r squared. Hope that makes sense. Now let's clean it up further. It's going to be SA of r is equals to pi r squared plus, then now we see the fact that this is the same as having 2r, so this and this are going to cancel out and this pi are going to cancel out, so we're going to be left with 600, right, divided by what? Divided by r. Hope that makes sense, right? So we're looking for SA of r. Since we need to differentiate it, we don't want fraction, so it's going to be pi r squared plus 600 r to the power negative 1. So now differentiating it, so it's going to be SA prime of r is equals to pi multiplied by 2, then it's going to be r2 minus 1 plus 600 multiplied by negative 1, then it's going to be r negative 1 negative 1. Hope that makes sense, right? So now it's going to be SA prime of r is equals to what? Is equals to 2 pi, right, r to the power 1, right? Then the other side is going to be what? It's going to be plus, not plus, it's going to be minus. So it's going to be minus 600, right? And it's going to be r to the power negative 2. Hope that makes sense. So now with that is that, remember the fact that we're looking for what? We're looking for this. We're looking for this, right? And maybe let's put this inside a box. So we're looking for this. Maybe let me make it another color, blue. We're looking for that, right? So we're looking for when S, but we're looking for when SA of r is equals to 0. So this is going to be 0 is equals to 2 pi r minus 600 r negative 2. But remember the fact that we're solving for r. That's what they said. They said the fact that determine the value of r. So with determining the value of r, I'm going to take the 600 to the other side. So it's going to be 600 r, what you call to the power negative 2 is going to be 2 pi r, right? So I'm going to rewrite this one. It's going to be 600 divided by r squared is equals to 2 pi r squared, right? R, just r. Yes. Then gonna take it, we're gonna multiply it on the other side, so it's gonna be 600 is equals to 2 pi r multiplied by r squared, which is going to be the same as 600, right, divided by 2 pi is equals to, I want r to be alone, basically. It's going to be r cubed. Hope that makes sense. So now cube rooting both sides, right? So cube rooting both sides, this is going to be the same as what? This is going to be the same as, okay, first before we do that, let's clean this up. So this is going to give me 300, right, divided by pi is equals to r to the power cubed. Hope I'm making sense. So we're going to cube root both sides. So it's going to cube root both sides. So it's going to be 300 divided by pi is equals to the cube root of r cubed, right? So therefore, punch this into the calculator. We find that r is going to be equals to what? To 4,57 centimeters. So that's how you'll solve for r. So now we're going to do probability, right? So with probability, we're going to do this question. It says event A and event B are independent. So what does it mean when event A and event B are independent? So for independent events, so I'm going to say independent events, this means this is true, is that the probability, right, of A and B, which is the intersection, is equals to the probability of A multiplied by the probability of B, right? So let's just put this in here. Okay, go back. I just want to do this. Put this here, right? Because we're going to use it. Right, so that they tell us the fact that the two events are independent, so we know this. Then they tell us that the probability of A is 0.3 and the probability of B is 0.6. So from that is that since we know what's the probability of A and B, we can find the intersection, which is the probability of A or B, which is going to be equals to 0.3 multiplied by 0.6, right? And we see that the probability of the intersection is what? It's 0.18, right? So we have the probability of A multiplied by the probability of B, which is the intersection. The second part says represents the given information on a Venn diagram and indicate the Venn diagram and the probability associated with it, right? We see the fact that we have two events, and since they told us the fact that the two events are independent, is that we see the fact that we have intersection. So we're gonna have two circles, right? So this is 10 point. So let me just, this is 10.1.1, right? So we're gonna have two circles. So let's have two circles. So we know the fact that this is going to be A duplicated and this is going to be B, and there's an intersection, right? So the intersection is here, right? So this is the intersection. We always start with the intersection, right? We know the fact that the intersection is 0.18, right? Then now we need to find just this portion. So we need to find this portion. So if this is A, if this is probability of A, and this is the probability of B, right? We need to find what this is, right? So we need to find what this is, this part of it, which is A, right? They gave us what? They gave us that probability of A is equals to 0.3. So 0.3 is the whole thing, right? Including the intersection. So to get just this portion alone, we need to subtract the intersection. So meaning it's going to be what? It's basically 0.3 minus 0.8, which is the intersection, which we found the fact that our probability of A excluding the intersection, we're going to get it as being what? It's going to be it's going to be 0.12, right? So it's going to be 0.12. Then same thing with the probability of B, right? B without the intersection, so it's going to be just this one, right? It's going to be this one. To do that is that it's going to be this minus this, and it's going to give us the part that I just showed. Right now, the whole thing, right, the 0.6 includes this. So we need to exclude it to find this portion. Hope I'm making sense. So it's going to be what? It's going to be 0.6 minus 0.18, which is going to be equals to what? Which is going to give me 0.42, right? So that is the probability of what? That's the probability of A and B plus the intersection, right? But we're not done, right? Because when drawing a Venn diagram, this needs to be in the square. Okay, so let me just erase this. Right, so this needs to be inside a square, right? So if this is inside a square, let me just remove the opaque. Yes, right. If this is inside, it's that we need to make sure the fact that when we add all the probabilities, right, it adds up to 1. So the remaining that is not 1 is going to be what's going to be outside. That is not going to be included. So that's not the intersection. That is not what? That is not A or B, right? Something that's going to be outside, right? So we know the fact that to do that, we know the fact that we need to sum all of them. And when you add them up, they need to add up with what? They need to add up to, it needs to add up to 1. So to find the outside part, finding the outside or neither A or B. So the outside part, right? We know the fact that it's equals to 1, which is the total, minus the probability of 0.12, plus I'm adding up this, and this, right? Hope that makes sense. So it's going to be 0.18, then it's going to be plus 0.42, right? So we know the fact that when you punch that into the calculator, you're going to get it as 0.28. So we know the fact that if I add this plus this, I'm going to get 1. Hope that makes sense, right? So this, the outside part is going to be what? The probability of the outside part is going to be equals to 0.28. So that's how you would draw the Venn diagram for this. So now we're going to answer the question. It says determine the probability of B only, right? So the probability of B only, meaning is B not including what? So it's B, right? Not including the intersection. So it's this portion here. So that is going to be equals to that. That is B only. So that is going to be equals to what? To 0.42, right? And maybe just to do it is that I'm just going to take this, right? And use this diagram to answer the following questions. So let me just put it here. Right, so let's do this, and I'm gonna shade what they want. B only is equals to this part, so this part is B only. That is the probability of B only, because it doesn't include the intersection. Hope that makes sense, right? So this will be your B only. So when you use your Venn diagram, that's going to be your B only. So now we're going to do B, right? They say they want the probability of B. So B, remember the fact that is this whole circle, right? So it's going to be this whole circle. So let's highlight that whole circle. So we know the fact that it's going to be this whole circle, right? So it's going to be this whole circle. So that is what? That is B, right? Then O means we adding. So plus the probability of not A. So it's everything that's outside, right? So everything that's outside, including the probability of B, is not A, right? So this is going to be the not A. Hope that makes sense, right? So that is going to be everything that's outside. So it's going to be everything that's outside as I'm highlighting. So now what are we doing is that we're going to add. So it's going to be this plus this plus this. That is the probability of B, or means we adding not A, which is going to be equals to 0.18 plus 0.42 plus 0.28. When you add all those three together, we find the fact that the probability of B not A is 0.88. Hope that makes sense, Anna. So now we're going to do 10.2. It says the digit 0 till like 0, 1, 2, 3, 4, 5, 6, and 7 are used to create a 4. Very important. They tell us it's used to create a create a 4-digit code, right? Then they tell us the fact that how many codes, right, are possible if we are allowed to repeat. So repeat, like we are allowed to repeat. So now if I create like a code box, right? So this is a code box, right? And within the code blocks or code box is that this is the first digit, this is the second, this is the third, and the other one is the fourth. So let me just reduce it like this, right? So we have 1, 2, 3, 4, right? So what are we, how many numbers, how many options do we have, right? How many number options do we have? We see the fact that the number options, so the number options, right, is equals to what? Let's check. It's 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 options, right? So very important in the question, they tell us the fact that we are allowed to repeat, right? So we are allowed to repeat. So now for the first digit, how many options do we have? We have 8. Because we are allowed to, we have 8 options, right? So we can pick from 0 till 7. Then the second options, again, we have 8 because we're not taking away any number. The same option that we had on the first one is the same option that we have for the second one. And the same thing for the third and fourth. We see the fact that the how many possible codes that we can have, it's basically saying 8 multiplied by 8 multiplied by 8 multiplied by 8, which is the same as saying 8, since there are 4 of them, to the power 4, right? So if you say 8, right, if you say 8 to the power 4 to inside your calculator, you're going to see the fact that this is basically equals to what? To 4,096. So this is the the possible types of codes that you can create if you are allowed to repeat. Hope that makes sense, Anna. So now we're gonna do 10.2.2. It says if the code is not repeated, so if digits may not repeat, meaning we're not repeating any digits, right? How many different codes can we have? So I'm going to take this again, I'm going to duplicate this box, right? Because of it's a 4-digit code. So I'm going to cut it and I'm going to just paste it here, right? Then we're going to do it for if we're not repeating. Remember the fact that we still have 8 options. So I'm going to delete this, right? So for the first one is that for the first digit, right, we have, or for the first box for the code is that we have a complete of 8 options. So we have 8 options. But remember the fact that now we have used up 1, meaning the second option is going to be 8 minus 1, which is 7 options. Right, then for the third one is that we have used up 2, so it's going to be 8 minus 2, which is we have 6 options, and here we're going to be having 5 options. So now for this one, the possible, right, the how many codes that we can create is basically 8 multiplied by 7 multiplied by 6 multiplied by 5, which this is going to be equals to what? It's going to be equals to 1680. So this is the possible different codes that can be created. So now we're going to do B, right? It says calculate the probability that the code, right, code number must be between, so let's highlight. They tell us that the code number needs to be between 2,000 and 6,000, right? So that is the first condition. And the second condition is that that whole code number needs to be divisible by 5, right? So now looking at each condition, we're going to look at condition 1 and say the fact that how can we get that, right? So for condition 1 to be successful, so condition 1, so I'm going to say condition 1, which we want our number, so we want the number to be between, so we want our code, right, to be between, so to be between 2,000, right? So code needs to be between 2,000 and 6,000, right? So meaning the first digit, right? So meaning for the first condition, meaning the first digit, right, must be what? Must be the following numbers. Must be either 2, 3, 4, and 5. It can't be 6, right? Because, and I'm going to show you, right? If the first number, it's like 6. Okay, cool. So remember the fact that if the first number is 0, then it doesn't fall here. Because if you have your code, right? Your code, maybe it's 0. So maybe your code is 0, then 1, 2, 3, 4, right? So 1, 2, 3. Yes, 1, 2, 3. This 0, do you see the fact that it's not correct? It doesn't fall within this range. If it's 1, again, it's even if you do this, right? Do you see the fact that it doesn't fall, right? So that is why here our options for the first digit, right, can't be 1, it can't be 0, and can't be 1. And also it can't be 6. Reason why it can't be 6, because of if you have 6 and this is going to be maybe 1, 0, 1, right? Do you see the fact that this number is bigger than 6,000? So that is why our options is from 2 till 5. Hope that makes sense, right? So the first option, that is why it's that. So now taking the box, so let me just paste it. Okay, cool. Okay, let's erase that. Okay, I thought it's like I still have the box. So let's take this box, duplicate it, cut it, right? So we're gonna paste it here. So now we see the fact that for the first number, right, the options for the first digit, so options, so for this one, right, options, we know the fact that is what? It's 2, 3, 4 till 5. So how many options do we have? 1, 2, 3, 4. So here we have a total of 4 options, or what you call this option, right, to create this code. Hope I'm making sense, right? Then now moving to condition 2. Condition 2, they tell us the fact that the number, right, they tell us that the code, right, must be what? Must be divisible. So it must be divisible. So it must be divisible. So it must be divisible. Yeah, divisible by 5. So something to be divisible by 5, to achieve that, right, is that the last digit, so is that the last digit, right, either needs to be 2 options, right? So the last digit must be what? Must be 2 options, which is going to be 0 or 5. So it's either 0 or 5. So the same question, if they say the fact that it's divisible by 2, so meaning your last digit again was going to be 0 and 2. So depending on what the situation is. But for that to happen is that the last digit, if it's 0, when you divide by what? When you divide by 5, you're always going to get like a complete number, right? Or if it's 5, then that's going to happen. Hope that makes sense. So meaning the last digit affects the divisibility. Hope that makes sense, right? So with that said, I'm going to take this again, right? I'm going to take this. So I'm going to duplicate it, cut it. And now we're going to fill in the last part, right? So we know the fact that the first part is this one, then this one, the options that we have from the conditions, right, is going to be 0 and 5. So now the options are 0 and 5, but now we have a slight problem, right? Remember the fact that this 5 is also included here in the first digit. So we need to look at it in 2 cases. What happened if the first digit is what? The first code ends with 5, ends with 0, sorry. Then case number 2 when it ends at 5. Because of what's going to happen is going to be different. Hope I'm making sense, right? So now let's do that, right? So case number 1. So case number 1 under here. So case number 1, right, is that we know the fact that the number ends with what? The number ends with 0. Then what's going to happen? So we know that the first digit is always going to be 4. So let me just copy and paste this. Duplicate, cut. Yes. We know the fact that the first one is going to be 4, right? And that is because of our options is 2, because of this is the options, right? Because of this is the options. So duplicate, cut, right? So I'm going to just put it here, paste it, right here, right? So we know the fact that our first option is going to be 2, 3, 4, and 5, right? So now we know the fact that if it ends with, if it ends with 0, this is gonna be for the first option. Then remember the fact that we specifically said the fact that it ends with 0, right? Meaning the last one, 0 is one choice, meaning here the last choice is going to be 1, right? Then we need to look at the numbers that is in between. So now the second code, right? The second code, how many options does it have? Is that from 8, right? So from here is that it's going to be 8. Remember that our total number was 8, right? But we already have the first choice and the last choice. So it's going to be 8 minus 2, which is going to be equals to 6. So here's going to be 6. Then remember the fact that we're not repeating here, right? And for this one, right, it's going to be what? It's going to be a total of 8 because of there isn't any special conditions between the middle terms, right? So it's going to be 8 minus what? Minus 1, 2, 3, because we have already 3 options. So it's going to be minus 3, which is going to give me what? It's going to give me 5. So here it's going to be 5, right? So this is the code for what? For when it ends with 0, and 0 is one choice, right? That's why we have 1 here. So now, so one choice, so options, just to show you, since we said the fact that we explicitly say it ends with 0, so it's going to be 1. So this is one choice, so I'm going to say this is 1, 2, 3, 4, 4 choices. And this is going to be one choice, so that you can see where it comes from, right? So one choice, right? So this is going to be the same as what? This is basically the same as saying 4 multiplied by 6 multiplied by 5 multiplied by 1, which is going to be equals to what? It's going to be equals to 120. Hope that makes sense, right? So now we're going to move to case number 2, right? Case number 2, the number ends with 5, right? So the number ends with 5, right? So what's going to happen? So I'm going to just take this again, and we're going to see how it changes. So duplicate, cut. So it's going to be here. Maybe let me just do it here. Yes, right? So if that's the case, we're always going to start from the back. So I'm going to erase this, right? So I'm going to erase this. We're going to start from the back because we know the fact that we have one choice. So the options for this one, so erase, erase, erase. So the options for this one is just 5, right? So it's one choice, right? So it's one choice. So meaning here it's going to be 1. Hope that makes sense, right? So since we know the fact that it's one choice here, then we move to the first term, right? So now with the options in the first term, so options, it's going to be what? It's going to be 2, 3, 4. But remember the fact that we already have 5. So here, that is why I don't include 5, because we're not allowed to repeat. So here our options is 3. Then here in the middle is going to be the same with this one, right? So it's going to be 6 and it's going to be 5 because they're not affected. Hope that makes sense, right? So now, right, that is the same as what? That is going to be the same as what? This is the same as saying 3 multiplied by 6 multiplied by 5 multiplied by 1, which you're going to get as being 90, right? So now the total to create this type of code, right? We're going to call it what? We're going to call it the code, right? We're going to call it the code, right? So the code, right? The total code, so the total code outcome, right? Outcome, it's basically equals to what? To 120, which is this option. Remember the fact that it's going to be this one and this one, right? Or, and or means what? Or means adding. So it's going to be 120 plus 90, which is going to give us what? Which is going to give us 210. Hope that makes sense, right? So now to find the probability. So the probability, right? The probability is basically going to be equals to this one, which is going to be 210, divided by the total outcome if it's not repeated. The total outcome without repeating, right? Without repeating, it's this number, right? This is the one that we did, finding the code if the number is not repeated. So I'm just going to copy it duplicate. Ooh. So it's going to be this one, right? So it's going to be divided by this one, the total outcome, right? Then this, therefore the probability, right, when you punch that into the calculator, it's going to give you 0.125. So that is the probability if it satisfies this two condition, meaning the fact that the code is between 2000 and 6000 and the code is divisible by 5. So that's how you would solve this question.